Good afternoon, ladies and gentlemen. How is everyone doing? Everybody's okay, full of energies, happy? I don't see energies today here. What's going on? Thank you very much for joining a very special edition of the online technology meetings. Today we talk about co-packaged optics. So it's a great day because we have companies from all over the world, from the US all the way to Asia. We want to establish a way of working together. So today is the number 26 of the online technology meetings. So I'm going to just show you how well it looks from the very beginning. So when we started on the 1st of April, Anna thought we were completely crazy, having to organize 39 meetings in about 3 months, but we are managing, we are surviving, we are looking great. Look at Anna, she's full of energies today. And we also are getting a lot of fantastic feedback from many of you. So for that, from the bottom of our hearts, we really appreciate how much you are getting out of these online technology meetings, and we're getting crazier and crazier every day. So crazy that now Carlos came up with the idea of doing this for 24 hours. So on the 24th of June, I'm going to be 24 hours in a row, non-stop. I'm totally nuts. 24 hours talking about photonics with speakers. We're going to start with speakers in New Zealand, Southern Photonics in New Zealand, and we're going to finish in California talking to Brandon Collins from Lumentum and Werner Kress from Microsoft. So top people, 24 hours, the best speakers we could find in every country in the world. And also, I would like to remind that for those of you who have no idea what's going on with the standards now in Datacom Telecom, on the 1st of July, I'm going to sit down with David Law and John D'Ambrosia, and we're going to go through all the different standards being developed for IEEE, especially on the beyond 400G, but also talking about the automotive sector. We really want to line up with IEEE on what is going on with the standards, because maybe you are almost as lost as I am. And also, I would like to thank all the 564 members of EPIC, 21 semiconductor, microwave photonics, and the Skyline Optics sent the membership form last weekend. It was a busy weekend for me. Thank you very much for joining EPIC. We keep growing. We cannot do this without the support of the industry. Thank you so much. I would like to remind all of you that you all have access to a long list of market reports. So all of you, please go from time to time to the EPIC website. If you're an EPIC member, you can download 17,000 market data from there. I would like to highlight, for example, we had the market report from Joel on photonic integrated circuits, especially focused on silicon photonics. And my favorite part of the market report is when they take one of the Intel transceivers and they open it up and they look at every single component that is inside and who is the vendor for each component. So I really like that particular part of the report. So just have a look at those reports, and if you cannot find anything there, contact Anna. She has read all of them. She has memorized them. So she will tell you exactly where to find each and every one of these 17,000 view graphs. And apart from that, I would like today to tell you that I'm extremely happy because Anna and me have been working already for 4 years non-stop on bringing together the key companies in packaging photonics in Europe, especially for the datacom market. And when we joined forces with COBO and they told us the kind of things they were doing, we realized that we're actually doing the same thing. And later on, we met the Ethernet Alliance and they told us, let's work together. And this is the result of a lot of conference calls, a lot of emails, a lot of discussions, a lot of headaches. Sometimes we fight, and we fight, but we really like each other. So we always end up with a smile. She ended up with a beer and ended up with a non-alcoholic beer. Today, I would like to also thank the sponsors of the EPIC meeting. We have Axetris that make fantastic micro-optics for any market, from the automotive or gas sensors or flow sensors, but also great micro-optics for the datacom telecom sector. I would like to also thank VTT. VTT is one of our key partners that we have for the design and prototyping of silicon photonics. They have a really great technology in the thick SOI for very low losses. SUS Micro-Optics. I love SUS Micro-Optics. They are the wafer level optics partner whenever you need to go to high quality micro-optics for the datacom telecom sector. And they are also one of our key partners in PIXAP. They are providing the micro-optics for the co-packaged technology of silicon photonics. So it is great to have them with us. Optiwave, our great software solution for the simulation, design, and optimization of interconnects in photonic devices. And finally, Ficontec. If you ever go to Bremen, go around, go to Aachen, a beautiful area outside Bremen, and visit the floor plan. It's amazing. You can see all the Ficontec machines there doing what they do the best. Automation for the packaging and testing of photonic devices, from transceiver datacom all the way to LiDAR. Any photonic device, they can make a process automated and a beautiful machine for doing the testing and volume production. With this, I would like to give the floor to the smartest person in every room. Ana Gonzalez, what's in the menu today?
Thank you very much, Jose, for your always nice introductions. Yes, I hope you are as excited as I am today. I cannot wait to see what kind of collaborations we get today from this meeting. Yes, we have an amazing list of companies that are going to present. Peter O'Brien from Tyndall, Torsten from Ficontec, Scott from Intel. So yes, it's going to be a fantastic day. But well, these are not the only companies that are in the room. But we have an entire representation of the supply chain. Jose, if you can put the next slide. Yes, here, because the goal is to make a collaboration between the companies attending this meeting. And for this, what we need is a very good, real representation of the entire supply chain. I would like to start with the associations like the Consortium for Onboard Optics, the Optical Internetworking Forum, and the Ethernet Alliance for helping us to bring this list of end users and vertically integrated networking solutions companies such as Facebook, Cisco, Fujikura, TE, Hitachi, High-Tech, Intel, Nokia, because what we want is to know the challenges, how we can help them, how this fantastic supply chain in photonics can help them in their challenges with connectors, with transceivers. This is why we have here companies doing connector cabling, such as US Connect, also doing transceivers. I saw Sequoia, but we also have Dash Photonics, Nokia. But also we have companies doing WLDM and switches modules such as iPhonics. And it's not only that they are going to help end users with the challenges, but at the same time, they are going to provide challenges for the other levels of the supply chain that we have here. For example, for the packaging, assembly, and testing, we split between the companies doing equipment, but also the companies doing processes and services, such as, well, for the equipment, Ficontec, we have Ifotech, Teledyne, Kaisite, many companies, and also process and services, such as Fraunhofer, ICTM, Icon Photonics, Infotech, BTT, and many others. And also, well, this is a very nice level of the supply chain. The company is doing photonic integrated circuits. So we have the foundries, silicon photonic foundries, but also indium phosphide foundry services, and design and test services. And well, also for MicroOptics, we have companies doing wafer level optic production equipment, but also we have other companies doing wafer level optics prototype or production, and many companies doing market intelligence and semiconductor companies. And well, to finalize, just to highlight the European projects such as Passion, that is building a new infrastructure for a metro network that starts with the co-packaging of a pixel with silicon photonics, but also the pilot lines in photonics, such as PIXAP for assembly and testing, and also Fabulous for freeform optics, micro-optics, and that's it. Yes, did I forget something, Jose?
Nothing. You were perfect. You were spotless, smoothless. It's so great to work with Anna. An applause for Anna. She's working so great for Epic. She's bringing the whole European industry. She's actually the angel mind underneath this logo that you have here, the PixUp logo. That is bringing all the different companies in packaging photonics. I have one more thing to say, which is today we are live in YouTube. Well, every day we are live in YouTube. I'm getting used to my YouTuber life now. So for the people following this meeting in YouTube, if you want to contact any of the speakers today and look at the participant list that we have today, any of the participants today, if you want to contact any of them, send me an email, jose.pozo@epic-asoc.com, jose.pozo@epic-asoc.com, and I will introduce you to any of the participants today. Look what I'm offering here. And this goes also valid for the Zoom room. Any of you, if you want to contact any of the participants today, just drop me a line and I will make sure I make that introduction because I love working. I have no life. My life is yours. And with that, I would like to get the ball rolling. Let's get the ball to the people who know what they're talking about, or not just an me who like just talking. I have a great list today of speakers, but especially I have the director of the biggest thing that happened in integrated photonics in Europe. We have the PIXAP pilot line opening a new horizon of opportunities for all the photonic companies in the world. I would like to hear more about PIXAP.
Thanks, Jose, and thanks, Anna. It's great to see you doing so much to try and keep us all together, and hopefully we can see each other face to face soon. I look forward to that day immensely. So you can see my screen okay?
Crystal clear, Peter.
Yeah, perfect. Thank you very much. Okay, so I know we've only got 6 minutes, and many of you are aware of PIXAP and what it's about. And I think it's important I make sure mention all our partners. Tyndall manages PIXAP, but we have many great partners, and many of them here today. SUS, I see Wilfred is there. Some new partners have joined, and many established partners. And like this is really kind of a key view graph that I want to show, because what we offer in PIXAP is a range of standardized packaging technologies around fiber packaging, single fiber arrays, but also more and more we're seeing now an interest in micro-optics. And micro-optics for free space applications, because we're looking across many areas. So communications obviously is an important aspect of the customer base that we work with. But we're also starting to see interest in pluggable fiber connectors. And I would say in the last year, so PIXAP is running 3 years now, and we've started to make an offer of our packaging services in the last 18 months. In the last year approximately, we've seen a very significant growth in interest around micro-optics for example, edge coupling technology. So moving away from bonded fiber arrays directly to the PIC, as I say, we see quite a bit of interest on integrating micro-optics onto the PIC. So where be that silicon or indium phosphide or silicon nitride. I believe one of the big problems with the fiber attachment is things like solder reflow compatibility. So where the package, and quite often people are considering this, especially in the design of their product, that quite often these components have to be put on a printed circuit board in a system and withstand very high temperatures in reflow. So epoxy attach can be a real problem in that regard. That can be somewhat minimized. The stress on the micro-optics can be significantly less than a fiber, a large fiber array. So integrating edge-coupled micro-optics is something we've started to work on. And actually Ficontec now are based in Cork. They're in our labs, and that's a major project that we've started to develop, and we already have some customers interested in that. So the additional component is the ribbon fiber connector. For example, US Connects have a very nice light prism technology, and there's others started to look at that. So both for edge and grating couplers, we actually have now active commercial projects in that space. Other areas that we've brought in include photonic wire bonds and freeform micro-optics using the Vanguard process. So we have an array of optical and electrical packaging processes. And as I say, we've quite a few projects in that space now with customers. I would say that the micro-optics is a new area. For example, silicon micro-lens arrays, but it's definitely an area that's got a lot of interest. And that also ties in with something we're developing, because the idea of the pilot line is that it's sustainable after 4 years of funding from the European Commission. So as I say, we're in our 3rd year. So next year, we're basically finished you know, from a funding perspective with the European Commission, but we're in a very strong position. But not just from a financial point of view, we want to be technologically sustainable as well. So we're also now starting to introduce wafer level packaging processes, and micro-optics really is the way forward from an optical connectivity point of view. So that's an area I really want to stress, that, you know, wafer level micro-optic packaging and for pluggable connectors, fiber connectors, is an area we see great opportunity in. This is a nice example of kind of a physical demonstration of those different types of technologies. So this is a silicon photonic chip from IMEC, but we're also working with foundries around the world. We're starting to collaborate now quite closely with AIM Photonics in the US. And again, we have an array of design rules for electrical and optical, and we're just starting to introduce some very new design rules for micro-optic connection or packaging to the edge facet. We have a very nice technology demonstrator around design rules for edge coupling of micro-optics to the PIC. But also laser integration, so hybrid laser integration. And we're now starting to work on flip chip integration of lasers to PICs as well. So again, it's a process we're starting to standardize, but these, what you see here now, are already available. Flip chip of electronics, drivers and amplifiers. And also then you can see these are for pluggable micro lens arrays on grating couplers, so both edge and grating. And we've demonstrated pluggable connectors, fiber connectors to those PICs. And then obviously all the different types of wire bonding and interposers as well. So these are all available in PICSAP. There's a menu there. Our gateway then supports that. And this is just a nice example of a full demonstrator. So again, you can see at the center of that, the actual silicon photonic device, but then the RF, the DC, and the optics are connected via a pluggable connector. So it speaks to the kind of work that COBO is pushing forward. So as I say, for anyone interested, we have a single point of contact and we have a menu of technologies, adding to that menu continuously. And the bigger we're pushing now is pluggable micro-optics at wafer level packaging. We're a global pilot line, even though we're funded by the European Commission. And this is just to show the companies we work with throughout the world. We've quite a few in Europe, quite a few in the US. And as I say, we've quite a few companies now interested in the whole micro-optic integration on PIC. So I think that's about 6 minutes or so. So I don't know if there's any questions, or if the questions are for later, Jose.
Thank you very well, Peter. It's me. Thank you very much, Peter. Great presentation as always. Yes, we have questions, but before this question, what would you say that are the challenges that now you are facing in order to scale up the volume of packages? I mean,
Okay, so that kind of speaks to the way we've organized PICSAP. So essentially the way PICSAP works is we have our research institutes and we have our industrial partners. So if I go back to this view graph here, so we've got a number of industrial partners who take the scale up. So we're working with them to standardize the processes and to enable them to learn the kind of new processes we've developed so it can be transferred. So really the issue we face, or the opportunity those companies face, is that they can grow. So some of those companies like Fix and Technobiz have received quite significant investments recently to purchase more equipment to increase their capacity. So we will continue, as I said, to develop the technology sustainability and then working with our partners. So the objective is not that Tyndall will become a volume packaging partner. No, our job is to kind of refine, standardize, and implement new technologies and then transfer them to our industrial partners. The challenge for scale up, as you ask, is that those partners increase their capacity. And our job is to help them, for example, to help raise new funds, etc. Those kind of things.
So then what would you say for the companies doing automation machines? What would you say that are the main challenges in order to automatize the process? It would be fiber alignment in PICs, for example?
Well, if you look at many of the applications that we see emerging, like in quantum, sensing, diagnostics, fiber attach is not the big opportunity. It's actually free space. So for medical diagnostics, for example, this company here, Randox, you may never have heard of them. They're one of the world's largest suppliers of COVID-19 and different types of biosensors, and very big in veterinary healthcare. So, those types of biosensors are a growing market, obviously. They don't require fiber attach, Micro-optics is really a very large growing opportunity. No question about it.
Okay, and we agree on that as well. Okay, so we have a question from Mark. Yes, Mark from Fire Reality.
I assume you can hear me well. I'm originally from the Bronx, so I definitely project. Peter, a couple of questions. You advertise on your website that you're trying to get away from the valley of death. And I'm just wondering if your PPP, your private public partnership, was the exception in terms of getting, or will be the exception in terms of getting to companies to market, or is it the general time sink that I usually see with these sorts of entities? And also, why are you concentrating on COBO when this is something I assume the topic was co-packaged optics, and what do you see as the future for that? Because I'm terribly pessimistic on co-packaged optics. I'm wondering if you can convince me otherwise.
Well, specifically co-packaged optics. So the definition might vary across different I suppose people involved in the area, but no question about it. Micro-optic integration in the package and a move away from direct fiber bonding, for example, we absolutely see a great interest in that. We've actually had companies come in, and large companies, multinationals come in, and we've very quickly convinced them that the micro-optic approach is the way to go, and they can see the merits of that. It's more approachable more amenable to wafer scale packaging. So no doubt about that. Co-packaging of electronics with photonics, it's unquestionably the way forward. And it's also supports wafer level packaging. So, the interpretation of co-packaging, it can vary, but from where we see it, micro-optic integration for pluggable and for free space. So if you don't have your fiber there, it's free space. So for diagnostics and for pluggable fiber connectors, and also the co-packaging of electronics, no question there's opportunities there. And they're all supported by wafer level packaging. So that's really, where we see the opportunity. And the users speak, they support us in that. We can see that, big market opportunities. As far as sustainability and the valley of death, well, it's always going to be a challenge, the transition. What I would say is that the customers we see typically are, again, our focus from the European Commission perspective has been very strongly in SMEs. So we've started to bridge that. You're never going to fully bridge it, but it's been reasonably successful. We're sustainable. We're commercially and economically sustainable. But there's definitely opportunities for others to kind of move in and support it. But, it's been quite successful so far. And the companies we've worked with, they struggle to kind of one of the big issues we also see is the chip supply. So quite often we're not seeing enough chips coming through. So the volume and capacity of the foundries to be able to deliver on yields, reliability, we don't always see enough chips coming through. And I think some of the packaging industry partners, the pure play packaging companies, have concerns that are the volumes going to be there when they gear up to be able to package all of these devices.
Hey, Peter. So in PIXAP, we're receiving a lot of demand for packaging photonic integrated circuits, especially on silicon photonics. Now there is a big debate whether we should do the vertical coupling or we should go in parallel. Where do you stand on this, and what do you think are the advantages and disadvantages?
Well, if you mean vertical and grating, for example, as a grating and edge has many benefits. Mode size and polarization and spectral dependence. However, from a manufacturing point of view, grating coupling is ideal because it's more amenable to wafer level, whereas you have to separate and dice and separate the devices. So it really depends on the application. But definitely, we've seen about 75% of people are more interested in the edge coupling as opposed to grating, and that's principally driven by the specifications of the technologies. Grating has more limitations.
Today it does depend on the application, 100%. Today we have the field of Datacom Telecom here. I want to go to one of the success stories that we have in Europe on this. We have Sequoia in the room. Marco, thank you very much for joining this beautiful afternoon, at least here in the Netherlands. Where do you stand on this? Sequoia is one of the success stories of silicon photonic transceivers. Where do you stand on the way that to package silicon photonics, vertical grating couplers versus bad joint?
Hello, first of all, to everybody. Thank you, Jose, for this great meeting. I'm very glad to join this. And at Sequoia, we mostly work with grating coupler, but we look at all possible technology and packaging opportunity, of course. As Peter said, it depends more on standards. So edge coupling has a broad band spectrum for coupling, has less problem on polarization. But still, a lot can be done by grating coupler. So at the moment, we look more to grating coupler.
Another success story that we have in Europe is HHI doing the indium phosphide manufacturing for many customers. I cannot even mention them, but in indium phosphide, there is not much of a choice. We actually always do the edge coupling. Have you seen this as a limiting factor for indium phosphide-based transceivers going into the large volume production?
No, I don't think so. So actually, it's not public, but we have done also some circular gratings for surface coupling into indium phosphide because one of our partners wanted to have that. I personally believe much more in edge coupling simply because the fiber to the home industry with tens to low 100 modules in per year production volume shows us that there can be very cost-effective edge coupling geometries on an industrial scale. So, and my understanding, especially in high end, to talk a bit more about HHI, sometimes you fight for every 0.1 or 0.2 dB, and that's over the 30 to 50 nanometer spectral range, and then you are better off with edge coupling, I'm pretty sure.
Thank you very much, Martin. Whenever I talk about packaging, I need to speak to my friend Bob Musk, because he's been driving this industry for about 2 decades now and seeing what is happening in every single trend. Bob, thank you very much for joining this afternoon. We have heard a bit of stories already so far. What do you expect for a meeting like this?
What I was looking for was to understand a bit more about surface mount components in the optics world. It's been pushed for a long time. Lots and lots of manufacturers want the capability to use surface mount to mount the optics, and that means usually detachable pigtails, etc. But we're not seeing much progress in that area, to my knowledge, at the moment, which is a great shame. Okay, so COBO's actually plugging modules onto the board, but they're not surface mount. Peter mentioned earlier on there are issues with surviving the surface mount temperature profile, etc. But did some work 2 or 3 years ago, and that proved quite successful. In fact, back in 2002, a company called Corona Systems, unfortunately, developed a 40 gig surface mount transceiver, and that was using an MT connector plug-on, and that was water washable and surface mount compatible. That never came back again, but that was a good example of what you can do. And just going full circle, people are talking about edge connections and grating connectors. The other thing I'm looking for is somebody to come up with the evanescent couplers. And IBM Bromont did some work in that area, and I think Optiscribe have also been working on that area. And that provides an excellent coplanar coupling mechanism that's potentially a detachable connector as well. So I'd like to see some more progress in that area. Is that okay? Thank you.
Yeah, it is okay, because I had Dave from Embryonics nodding along to everything you said, like, oh my God, he's speaking the truth, but especially not along when you were mentioning the Optoscribe approach for evanescence. Are you working on something related from Embryonics?
Yes, so we've been discussing actually just this exact problem with Optoscribe recently, which I see are also involved in PixUp. So I'm sure Peter can talk more in detail about what their capabilities are. But yeah, it's very interesting what he's saying anyway.
But now that I give you the mic, what is Embryonics and what do you expect from this meeting?
So actually, we are currently working on a co-packaging project, which we just kicked off with IMEC. It's particularly being funded by the European Space Agency, looking at how we can reduce high-speed serial interconnect power requirements for satellites. And that's really our main interest in the actual miniaturization of the whole package design. So both looking at how we're integrating with the ASIC and really optimizing every single aspect of the package is key to actually saving power, as well as just co-designing the drivers and all these aspects. And I think it's really, you have to look at the whole architecture of the whole photonic system, really to try and gain these benefits. And that's really where our interest comes in. But again, the edge coupling versus grating coupling is a big consideration, as well as the micro-optics is the,
In the design and prototyping towards manufacturing, it doesn't get any better than embryonics. So I recommend everyone to have a chat with David whenever they are defining the product. Back to you, Anna.
Jose, I was just going to make a final comment there, if it's possible, just to Bob. Sorry, it's very interesting to hear about surface mount. We've started a program on surface mount BGA packages in glass, so and pluggable connectors. So actually out at the top of the package. So pluggable, fixable connectors on BGA, and they'd be solar reflow. So absolutely, fully agree with you. That's needed now.
Okay, thank you.
Okay, so if there are no more questions or comments for Peter, let's move ahead in the program. So it's my pleasure to introduce to you Torsten Vahrenkamp, CEO at Ficontec. So Torsten, hello. Would you like to? Very good. And now you can put. Perfect.
Can you see my screen?
Yes, yes. Perfect. So you can start when you want.
Hello, everybody. Very nice and big pleasure to present to you again. So Ficontec stands for Fiber Connecting Technology. We're actually a global partner in the world of fiber attach and photonic packaging and test. And we have approximately 800 machines supplied to major suppliers of photonic devices, specifically datacom telecom providers worldwide. Have approximately 170 employees worldwide and have pretty global footprint. So the head office is in Achim, as Jose mentioned already. Welcome to visit us here to see all these machines. We have a sales and support site in the US, but the major machine installation base is actually in China and Southeast Asia, rest of Asia, specifically Thailand, because some big subcontractors are located there. We see today very little co-packaged optics. What we are packaging is, so it's just for us as a provider for the industrial world. It just started. We provide a lot of different solutions, starting from machines for laser diode manufacturing, very high precision die bonding, lens assembly system, fiber attach processes, and test and characterization systems. And we're converting very, very slowly into the world of co-packaging optics. What we see there is pretty much the same what we see from front-side pluggable transceivers. We see actually what I mentioned here, fibers which are passively and actively attached. And I want to focus on the passive attach within this presentation. So we see here, for example, a system from Luxtera. And this doesn't mean that we do specifically this ones, but many others. So if you see one of those systems, you see, and this is actually a sketch of a machine, how it looks inside. There's a 6-axis alignment stage where we actually grip the fiber. It needs to be aligned in 6 axis. You have an input feeder, and you have a system where the bolts are kind of fed into. You have a conveyor where the components are traveling through, and then you have a system which is, when you have an active alignment process, you feed the or you have an auto fiber connect where you plug the input fiber or the outgoing fiber, or you're actually handling the cover glass for the passive attach. And if you have longer fibers, you need a cassette for coiled fibers. This becomes very important because we have a lot of customers which don't work with only fiber studs, like this little pieces of fibers with the connector. We have also customers which work like with fibers with up to a half meter length, and you need to leave this fiber somewhere in the machine. So this is what is our packaging equipment distinguish very strongly from standard semiconductor processes, because we need to handle the fibers. And these fiber handling processes becomes very tricky, and I come to that in the end of the presentation. So if you see the passive approach, so as an input, you have the fiber array, you have your chip with V-grooves, and you have a cover glass. When you go into the machine, you need to put and plug the chip, you need to lock it down in place, and you need to handle the fiber array to the V-grooves. And then you need to slide the fiber into the V-grooves, very gentle, and you need to monitor the fibers while you let them glide into the V-groove. So while you do that, actually, you monitor the back reflection from the surface of that fiber, and actually by having a look in the back, having a look onto the reflection of this fiber, you see if the fiber is nicely entered into the V-groove. And then you need to finally, if you don't want to have a touching, if you don't want to have the fiber touching the front side of the silicon chip, you need to monitor the gap. That is actually what's happening here. And this gap needs to be defined very precisely. Once the fiber is slightly and gently entered into the V-groove, you actually put the cover glass down. So after you have the epoxy placed here, you bring the cover glass and press down the cover glass with a pretty high force. So you need to make sure that the fibers are pressed completely into the V-grooves, and then you start the UV cure process. And finally, you handle the this fiber array or fiber attach is done. So there's a certain number of challenges. For example, if the fibers are longer than let's say approximately 5 to 7 centimeters, you need to leave the end of the fiber somewhere. So you most probably need to coil them. That becomes pretty tricky if you handle pretty stiff ribbons. So they do whatever you want, but not what they're supposed to do in the cassettes. So you need to have ways to manage these long fiber arrays inside the machine. Sometimes we have customers, they ask us to strip and cleave inside the machine. So the whole fiber prep process, they want to have inside the machine, which we do, but we have to do that outside the individual cell where the parts are handled, which are not allowed to see dust. So this dirty strip cleave process needs to be done in a separated cell. So you need to combine different cells with each other. So sometimes we have customers, they want to have the termination process inside the same same line or the same cell. Here, for example, an MT connector with a prepped ribbon fiber already. So all these kind of things you can do, and you can run in several steps. So as I mentioned, the co-packaging optic assembly is not done, at least for us right now, in a large volume. So we are in this area. So like standalone machines, even like lab systems where we show capability and feasibility. So we don't see that these type of machines right now in complete line configurations or cassette to cassette feeding, but we will see, or we see already that it will go there. So there's a lot of things to do. I totally agree with Peter that definition of co-packaging optics is not clear to us as a vendor right now what it finally means. So what I try to take out of this meeting is getting a requirement from the market. Where is this whole technology is heading to? Thank you.
Thank you very much, Torsten. Thank you for a great presentation, and thank you for posting the question of what is really co-packaged optics. This is not your first rodeo. This is an epic meeting, so you know the epic question. What can you do for them? What can they do for you? What kind of discussions are you looking forward to have after this meeting?
Actually, what I would like to see is we have a lot of individual discussions. We have a lot of questions if we can do specific things with our machine. And we always develop and reinvent the wheel all the time, because everybody is trying to do the same, but everybody is doing it a little bit different. And what we would like to see is a direction. It's like, we tried many times to come up with technologies which we offer to the market, but then it's finally not exactly what the specific customer is needing. So then we had to change the direction again. So we're heading in somehow the same direction, but not in the straight way, in my opinion. And I would like to have a little bit more direct way.
And I fully agree on that. One of the ideas of this is to really understand together today and the 1st of July, where are the standards going and where is the industry following them. Mark?
Oh, yes. I had a question for Torsten. I was just wondering, I think I was intrigued that you mentioned industrial. We know with the web scale operators, they're going to be looking to commoditize these types of CPO just like they've done in the past, only they're going to be doubling up on the commoditization, unfortunately. They look at servers and they say, well, we have to have the same kind of scale with servers as we do with optical technology. And there's not enough of an appreciation, at least by the bean counters at the top, that there's a difference between servers and optics. But my question for you is, for the industrial space, do you see enough differentiation, potential for differentiation, in that you can avoid this commoditization trap? Thank you.
To be honest, I mean, we are really end of the food chain. We are seeing tremendous price pressure, and we are forced either going up in speed, but there's a limitation. So that means we get permanently pressure on pricing for the machines, and it's for us. It's always the biggest competition is Chinamation, and especially the in-house machine building capabilities at our customer sites. So it's a lot of price pressure we are into, and it finally comes down to cost per piece. So I'm not actually. I don't know exactly if I'm the right person to answer that question.
But I know the right people to answer that question. And actually, you know, one of the highlights of the previous meeting that we had on Beyond 400G was for me to meet Jim Theodoras from AG Tech, because afterwards I introduced him to many EPIC members and he followed up with each and every one of them. So Jim, you are my hero. Thank you very much. What do you expect out of this meeting, Jim? What kind of collaborations can we do with AG Tech?
I think Torsten brought up a very good point. Right now, unfortunately, there's a lot of standardization MSAs on the definition of the channels, the electrical interfaces, the optical PHYs, budgets. That effort needs to move down further into the optical engines themselves. And I know a lot of companies think that's their secret sauce, or that's their, secret recipe, and that's where their value add is. But I think that time has long passed. Now there's more benefit to be had by everyone working together to more standardize these, because as Torsten said, every machine ends up being slightly different. Every optical engine ends up being slightly different. Every process fab ends up being slightly different, but they're all so similar. So if we could just extend that MSA work and the teamwork into further down the food chain into the optical engine themselves, now every one of the EPIC members can start targeting something that's well-defined, and you get this this economy of scale that's going to really push all this, push this forward in optical communications. So I think that's what we need, and I think these calls are a great first step. Making the introductions, working together. Everyone that you sicked on me, I've set up what I didn't call them business meetings. I call them brainstorming sessions. How can we work together to solve these industry problems? Because I think it's going to benefit everyone. So thank you. And thank you
epic
for the
online
introduction.
brainstorming meetings. I really love it. That's really what I want to do. And I want to introduce a new friend to the Epic family. Furukawa has been very active in the last weeks, engaging with us. Hideyuki-san, thank you very much for joining the meeting today. What do you expect out of this meeting, and what kind of collaborations would you like to start afterwards?
Okay, thank you very much for giving this good opportunity. Actually, I just understand that this meeting is held just 2 days ago. I received the email, and actually, Furukawa is particularly I'm working on the optical device side, particularly active device. Just looking at the co-packaging application, also the silicon photonics technology. We are setting the laser chip. Laser chip is very small portion, and also the business is becoming shrinking. We are providing the packaged lasers, packaged transceivers, but if we sell the laser chip, as I mentioned, the business is shrinking. Then right now we are looking at the next generation in the on the way of the transition. Let's see, the architecture. So then the co-packaging should be the very, very promising, and it should be the key technology and key architecture. Then I'm really thinking, you guys, what kind of thing you are looking, and what is the market of this co-packaging. So that's why I decided to join this meeting.
So for you,
if we have something, it will be good.
The point of this meeting is to find reasons to work together. So there are many people who want to interact closer with you. So it's already a great success that you are here. Thank you very much, Hideyuki-san. And we are going to continue with the program, and we're going to go to the fancier looking speaker we have today in the show. Thank you very much, Teledyne, to be represented at the meeting today. We want to understand reasons for us to working together and to test our chips with the best oscilloscope you can buy in the world, because I did a lot of linear dynamics measurements with the Lacroix. The floor and the attention of everyone goes to you.
Well, good morning, good afternoon, good evening, good night, depending on where you're coming in this time zone. I am representing the Ethernet Alliance in this call, although my paid employer is Teledyne LaCroix, so my Ethernet Alliance hat. The Teledyne has done a lot of things in the test and measurement space, obviously. We've been around for quite a bit of time. We have both the physical tools as well as the protocol tools. I represent the protocol house. So the way I describe it is the physical, the scopes and BERTs and whatnot, let us know that we have a productive and active roadway, and protocol tools let us know that we're driving the appropriate car or vehicle on that roadway. With that, let me move into the Ethernet Alliance components here. You guys can see my screen. I'm sharing properly. Anna?
Yes,
okay.
yes, we can see very well.
Double checking, Ethernet is the backbone and the technology of the meeting with which we're having today, whether you're on a Wi-Fi connection or whether you're on a wired connection. The function of Ethernet is to provide that roadway for us. So the Ethernet Alliance is a consortium, a group of end users, system vendors, and component suppliers that have come together to effectively test and ensure that the products that we have work. The Ethernet Alliance mission, as stated here, is basically to promote the awareness and acceptance and advancement of Ethernet technologies across the board. And we standardize on the existing and emerging 802.3 standards as our function and our focus. Although, as Jim pointed out, there's a lot of MSAs and interactive sessions like one we're having today, where we work with other organizations and entities to promote Ethernet opportunities. We like to accelerate the industry adoption, and we do that by trying to remove barriers. This meeting is a perfect example of that. And one of the keys to that, and I'll focus on here in today's meeting, is the demonstration of multi-vendor interoperability. And last year, we met the folks from EPIC at the European Conference for Optics, the ECOC show. So some of the ways that the Ethernet Alliance facilitates our mission is through these focused strategies on the screen right here. as I pointed out, interoperability testing, thought leadership, and promotion of Ethernet in a variety of ways. We also do some new things now with interoperability assurance. So we put together the Power over Ethernet certification program. That was demanded by the membership to find a way to show that things actually work together. And very much like the USB model or PCIe model, we put together a program that allows for independent tests and verification and validation of products actually operating together. Point out not enough coffee. A collaborative interaction with other industry organizations, as I spoke to, working with the EPIC people and finding a way to share the message of Ethernet Alliance and its abilities to generate interest and prove technology works with the community at large in Europe. So we do have a global outreach. We have members from all over the world, literally. And then again, in the promotion of Ethernet, we have a broad spectrum of industry analysts, educational outreach, and then a lot of marketing. So our members really dictate what we do and how we do it. Some of the things that we have done over the past several years, this is a short list, but plug fests. We bring together a lot of the members, and there's quite a few companies on this panel today that are members and come together to quietly and effectively test the interoperation of new products and new technologies. Two of the most important ones over the last year were the high-speed networking, where we're testing 400 gigabit interfaces on OSFP and QSFP-DD, those boring passive cable interconnects. And then the N-base-T Alliance, which became part of the Ethernet Alliance. So we have, from single pair Ethernet up to, high density coax and fiber interconnects that we're actually testing in these plugfest environments. I already alluded to the PoE certification. We've just released the .3 BT specifications or testing specification. Of course, the IEEE specification has been around for quite some time. And then the public demonstrations. We take these plugfests, we take these certifications, and then we show them to the world, to the buyers, to the interested parties out there through a variety of different means. The most demonstrable, obviously, is public demonstrations. So Optical Fiber Conference, Supercomputing, and the ECOC show, and others as indicated by our member companies. As a brief recap over the 2019, because of course, since the onset of coronavirus, we had trade shows here, but the Optical Fiber Conference 2019 San Diego, these are the pictures of that show. Unfortunately, the spaghetti map here kind of indicative of the environment of test and prototyping our products or across the industry. It's not a sexy wire wrap situation. This is actually real working. Everything in this rack is functioning at this point. But we had a booth demonstration from 10 gig to 400 gigabit E with multiple fiber drops throughout the show floor. So we introduced to the Optical Fiber Conference community the idea of having a live, SC's been doing it, Supercomputing's been doing it for a while, but as a industry organization, we dropped fiber into the floor to our member companies and some of the SIGs that we participate with, and actually had live demonstrations of a variety of technologies over fiber. The participant list was a pretty strong one with switch vendors, NIC vendors, and I don't want to say more importantly, because that's kind of self-serving because I'm in the T&M market, but test and measurement is showing up exceptionally strong in these environments, because without test and measurement, we can't prove the concepts that we've talking about either publicly or in these privately behind the walls of our companies. So we also hosted a panel there with the interoperability. We had several top speakers that were members of the Ethernet Alliance who participated. In the graphics on the right, this is the actual booth. Some of you may have seen that. And we actually carry our own equipment down there as well. So once we get these things set up and configured, we take it down and we stash it and we take it to the shows. So as I alluded to earlier, we met a lot of folks from the EPIC team here at ECOC in Dublin in September of last year. Slightly smaller participant list, but the same messaging, and I think the overall impact was very similar, which is a lot of disparate companies come together to make these and show that technology works across the board. So we didn't have any live fiber drops, but we did have a substantial amount of technology running from 10 gigabit twin ax all the way to 400 gig passive copper and an active fiber. So strong support from the test and measurement community again, as well as several of our switch and component vendors. This group over here, this is the gang of ne'er-do-wells who was helping get everything set up. So we have, and this was our live show floor from up above. Wonderful venue, I might say, and of course, being able to go to Ireland before the COVID was a lovely thing. For those of you that are interested in more information about the Ethernet Alliance, this is our contact information and the pages in which we do a lot of social and web work. So you're welcome to participate. Membership, getting on and getting information about what we do is easily accessed through the website. And then follow us on the socials and you'll see some of the things about webinars that we do and other activities. And with that, I'll pass it back to you guys. Thank you.
Thank you very much, David. A great presentation. Okay, so what would you say that are the companies that you would like to attract to the Ethernet Alliance? I mean, what are the companies that you think this company is missing or this kind of companies are missing?
What kind of companies? It ranges the spectrum, Anna. We have component suppliers, Source Photonics, Lumentum. I don't want to name names, but we have optical providers for both transceivers and fiber. We have test and measurement, a strong number of test and measurement companies. We have Cisco, Arista, switch and product companies. So it really is an amalgam of everybody within the ecosystem to try and figure out how these things work. There's a lot of focus, obviously, on high-speed interconnects today because of the movement in 802.3. But we also have a lot of people working on 1 gig, 2.5, 5 gig base T for power over Ethernet. So wherever you sort of see the benefit of Ethernet Alliance, these companies come together. Jim Theodoros, I worked with him last year on the board with the Ethernet Alliance. So we're all over the map as far as membership is concerned.
Okay, perfect. I think we have a question or a comment from Mark.
Yes, thank you very much. And actually, even when I'm presenting, I don't do sales pitches, but I do want to just quickly say, as an EPIC member, that go to fiberreality.com/store, and we have a totally new report on Sienna facing commoditization and what they could do about that. Commoditization meaning, of course, on the web scale front. But I do have a question for David. Do you see you mentioned OSFP versus DD, and that's an issue with 400ZR or will be as those products come out. And splitting the market like that is going to create some pricing issues, I would suspect. But are you, or maybe you don't want to take a stance on it, do you see as we get to 800G that the OSFP will be more compelling?
I don't, my crystal ball is as cloudy as the Mississippi, but my take on it is we max out the DD, the QSFP DD at 800. And that's where the sweet spot starts to pick up for OSFP as a technology, an interconnect technology. With speed comes power and heat. So heat dissipation was one of the key issues behind the design of the OSFP interface. So I think as you move into the higher speeds, the higher per link and per port speed characteristics, OSFP becomes more popular. But there's such a legacy. I mean, this was the whole debate moving forward. The camp that went QSFP DD said, we want to support the legacy implementations. We know that there's a limitation once we get into these higher bandwidths. And then the camp that said, let's go OSFP said, well, we're not really concerned about that. And we believe that there's ways to interoperate. To that effect, I actually tested an OSFP to QSFP DD DAC. So I was able to convert electrically. There was no difference. It's just a matter of connector interface. Optically, of course, now I have to figure out which is going to have the sweeter spot to be able to get my money and my return on investment for investing in one of these two interconnects. It's obviously market, there's some companies that are saying, well, we've already got the QSFP interface. We're going to be fine with that. We're going to move forward with OSFE for high speed connections. So, it's the VHS versus Betamax wars a little bit differently.
Okay, thank you very much, David. Maybe it's a good moment now to introduce you one person in this room, Giovanni from BTT. Would you like now to tell us maybe about how you are integrating these pixels with silicon photonics for the Passion project, or well, in general, what kind of activities are you going on in BTT?
Well, thank you, Anna. Can you hear me?
Yes, sure.
All right. It's a great meeting as usual, and this is a great opportunity also to say that in addition to what has been said a few minutes ago about the way to efficiently couple light into fiber, whether arrive vertically or just back couple, I would like just simply to say and remark what we are scouting now in Passion, and that is using mirrors. Mirrors are an efficient way to escape from the limitations offered by coupling gratings as well as the bad coupling, and offer absolutely insensitivity to polarization, and of course cover the overall optical bandwidth that, for instance, our silicon photonic platform is able to cover. So basically from 1.2 up to 4 microns or even more. So turning mirror are definitely a solution. And we can discuss if the coupling strategy can arrive from the vertical on the mirror, or as I strongly suggest, to use MicroOptics to parallelize. So basically to convert again from vertical to horizontal, because vertical also for mechanical reasons, as you can imagine, is not really the way to offer reliable solution. And as Peter said before, no questions that MicroOptics will play an essential role in that. And it's true because from the mirror to the fiber, you need something in MicroOptics to tilt the beam again 90 degrees and to go flat and parallel with your silicon photonic solution. That's the way, and that is the approach that we are doing, whether in Passions but also in other applications. So that is basically my feeling. In addition to the fact that the mirror is bidirectional, so it means that you can collect the light, but you even can launch the light in. In Passion, for instance, we use mirror to couple lights into 3 micron SOI waveguides. That is our platform, using VCSEL, for instance, and successfully demonstrate. So that is a great opportunity. So in addition, just simply to say that mirrors are always possible and an effective way to really be to offer integrated solutions and not bulky. Anyone in the telecom want bulky things, want everything to shrink everything in the minimum volume possible. That's basically what is by my side.
Giovanni, yes, also mirrors.
Thank you, Anna.
Vertical coupling, also important to take into account. Any challenge in the fabrication of these mirrors now that you have in the packaging of these transceivers that we are building in Passion? Now you have all the community here. So do you have any challenge to share?
Well, challenges are always in any process. The good things is that we offer mirrors also in our PDK. So it means that these mirrors has been well tested and the process to realize that also stable and well defined. So it's and PDK is the way to is the easiest and less expensive way to try and to test this technology as well.
Okay, so I think we have Wilfried here that wants to comment about this. Wilfried?
Yeah, thank you, Giovanni from BTT, for bringing up the mirrors. So we also offer mirrors now with micro lenses. So basically, you have a mirror integrated in the micro lens array. This has already been, we already have clients there using this for datacom applications. And this is a way to go for co-packaging. I clearly see that too. You have to increase the number of features. You have to increase the number of packaging elements. So for the assembly and also for the optics, you have to make it more compact, everything. And one way, of course, is to integrate mirrors. And we're going exactly the same way with microlens arrays. And it works. So the first data that we've seen, they're great. So of course I can't tell you who's doing it, but it is fantastic that it works. So.
Excellent, Wilfried. I totally agree, and I totally can share your comment and also your satisfactions. We have also tried to design our say micro-optic structure to convert the vertical beam from the mirror to horizontal in a very small form factor, so very small micro assembly, and the fiber in this moment is still glued with this kind of micro assembly, but the micro assembly can come in an array form, so 4, 8, 16. In this moment, I cannot imagine bigger than that, but definitely fair enough, more than adequate to the existing application. And okay, I don't want to steal more time.
I mean, we mentioned that already last time, that there is an interesting difference between telecom and datacom. In telecom, we see very large arrays with very high densities. And Tom from what's his name from Molex said that already last time. He said there is a difference between telecom and datacom, unfortunately, but telecom has done basically very dense packaging already for many years, and they have pitches of 80 microns, 127 microns, and they're very close packaged, very complex devices, but definitely at a different price level. So so we're still waiting for seeing to see this transition from telecom to datacom in terms of technology. I think COBO, the goal is very high, so this will be very disruptive, like Jose always emphasizes. So it must be disruptive in order to have a chance. And I think the goal is so high with COBO that it's not a gradual change from the current transceiver technology to COBO, and that will take time, and there will be a lot of challenges in the technology. At the price level, that is, and
actually don't think the price is going to be the problem here. I think here the problem is that the losses with the interfaces. Jim from Agitech, I think we are seeing little by little that the 100G electrical channel is a problem. We have to move to the 200G electrical channel, and that's going to create like a new jungle. How does Agitech feel about this unstoppable transition?
Oh, well, so I think, okay, so a point people are missing. So I kind of cringed a bit when I heard earlier, let's make surface mount optics. And right now we're at 100 gigabaud going to 200 gigabaud on the electrical bus. And early channel modeling from the connector and package vendors are showing that the package budget, the package loss is greater than the whole link budget that you're trying to achieve. So that's why there's this concerted effort of the industry to look at CPO, co-packaged optics, is that realization that longer term, the package itself is going to, just getting out of the package is going to eat all of your budget at the higher speeds needed to move forward. So that's why let's bring the optics on the same substrate It can be any substrate, and COBO actually has a big roadmap of like 8 or 9 steps of gradually getting there, but we need to gradually take out more and more of those interfaces, and so that the link budget you do have is being used for your link, not for the package itself.
Am I getting this right? In your mindset and reading between the lines, that you think that the co-package optics are an intermediary step to having electronics and photonics integrating the same epitaxy?
It's a good first step, yes. So the end goal is total integration, but we have to, crawl, walk, run. And so the first step is COBO. Then the next step is maybe co-packaged optics, and the next step after that is actually taking it one step further.
But we are investing a lot of money on this intermediary step. So maybe we have to consider circumventing. I'm going to introduce you to a company who has been invested heavily on helping companies maybe circumvent the first step. Vario-optics, a company that we have in EPIC, on integrating optics in the PCB boards. Thank you very much, Felix, for being with us this afternoon. Tell us how we can speed up this process, because I see a lot of intermediary steps. The floor and the attention now of everyone is yours.
Thanks a lot, Jose, for this tactical introduction. Let's just first share my screen. Can you see it?
Crystal clear.
Do you still see the presentation mode?
Crystal clear. The floor is yours.
Okay, then I'm happy nothing happened between the test and now. Thanks a lot that I'm allowed to talk about our technology. We are working exactly in the field of photonic boards, electro-optical circuit board, and we might have some solutions for the next generation or for the next steps for the integration of electronics and optics on board. I will talk first about vario-optics and our technology in a nutshell, but I would like to focus then on two samples which we actually realized. One for co-packaged optics, and one was a further step where we realized optical chip-to-chip communication. vario-optics is a small SME based in Switzerland, in the very east. We are focusing on the manufacturing of electro-optical circuit boards or photonic substrates. We also support our customers in the design and development of their electro-optic systems. We work in different markets like sensor applications, photonic packaging, and high-speed onboard communication. This is the concept of our technology. I think that the concept is known. It's nothing really new. We have somewhere a photonic layer or an optic layer with either polymer or glass waveguides. The glass waveguides we usually work together with Fraunhofer and ICETEM in Berlin. They do ion diffusion. The polymer waveguides are defined using photolithography. So somewhere you have such an optical layer. It can be in the inner as an inner layer, or it can be an outer layer on the surface of a conventional PCB. You see here such a cross section. In the middle there is the optical layer with here 20 electrical layers. We work usually in large formats up to 305 times 460 square millimeters, which is the smallest PCB panel format. We provide different interfaces. That was also a discussion before. For multimode, we have a solution based on a mirror device for vertical coupling, but we also can provide edge coupling or adiabatic coupling, evanescent field-based coupling. We don't do assembly of components. That's usually the first thing which is asked. but we provide very precise assembly features which support passive or vision-based assembly of such components here. As I already mentioned, I would like to explain the benefits of our technology based on realized projects. The first one is out of the EU project COSMIC. There we had to develop an optical fan-out board for a 2.4 terabit per second onboard optical transceiver. The basis here was a diabatic coupling, so evanescent field coupling, where we realized quite good losses, which were below 1 dB. The other nice thing about the diabatic coupling is that you have relaxed assembly tolerances. The two waveguides, the taper on the silicon side and the polymer waveguide, they don't have to be aligned very precisely to each other, so they only have to touch each other. That means that the width of the polymer waveguide is more or less the assembly tolerance with this coupling scheme. It also supports a broad wavelength range, so WDM coding can be realized. And what I have mentioned before, we realized the fan-out to passively assemble glass fibers. Here you see the concept which it bases on. So on our waveguide, on the waveguide side, on our photonic board, we can realize very precise assembly features. They are defined during the same photolithographic curing step, and therefore they are aligned within submicron precision to our waveguides. Another element which we are using is a device with V-grooves, can be a silicon device with edged V-grooves, which can be plugged onto our board like a Lego brick. So it's quite easy to assemble. On the other side, it acts as an assembly aid for glass fiber ribbons. It was also shown within this project that one can realize repeatable good losses in the range of 0.3 dB between a waveguide array and a fiber ribbon array. What is also interesting, that was a discussion before also about MicroOptics. So such kind of alignments strategies can be used for to assemble further components like lenses or active components. So that's quite a good basis for a cost-effective assembly. The other sample I wanted to bring up is out of the EU project streams. There we had to develop a substrate now with electrical traces also for high-speed optical chip-to-chip communication. The coupling also based here on adiabatic coupling, same principle as before within COSMIC. In order to realize that, we had to provide a very flat and substrate with very high planarity in order to support simultaneous adiabatic and electrical coupling and bonding also. You see here in the lower left such a picture of such a big area with the naked cores here. I think they have a pitch of about 30 micrometers. Then you see also the electrical pads around it. In the middle, you see the flip chip pick onto the board with the different necessary additional components. The optical losses we realized here was in the range of 0.5 dB per centimeter at 1310 nanometers. With glass, it would be much better. We also were able to show that with this technology, we can realize also very good RF electrical properties, which are in the range of the theoretical values given by the dielectric substrate vendors. Interestingly, at the end, we also that was made by the University of Athens. There was also a comparison done between state-of-the-art electrical bus systems like the QPI of Intel with this optical transmission system, and we were able to show that you can realize 70% power reduction compared to electrical communication. So that's quite an impressive number, and I think it's one of the arguments why to switch more and more from electrical chip-to-chip communication to optical, and hopefully that will be realized within the next generation or the next development steps to the next generation products. So I'm at the end of my technology and my speech, sorry. Our technology goes on. But I also structured the conclusions like Jose likes to have it. So we can offer a completely new approach for optical co-packages and chip-to-chip communication by highly integrating the electrical and the optical interconnects. We can provide with that very high data throughput on board that's compared to an electrical system. But we also can support low-cost packaging at significant power reduction. And we are looking for innovative partners which are willing to use our technology and to benefit from the advantages we can offer with this technology. Thanks a lot. I'm open for questions.
Thank you very much, Felix, for a great presentation, and thank you for bringing a little bit more light into this topic. Mark.
Here we go. Felix, I'm not going to just unload on you, but I want to get the rest of the audience, including Jim, who suggests that we have to go beyond CPO. I think some of us aren't even going to be around to see CPO. That's just my opinion, I guess. So maybe it's a couple of lifetimes till we get to the promised land. I mean, who's pushing for CPO? It's Microsoft and Facebook. Facebook is probably the least disciplined when it comes to costs on optics. Microsoft has come up with all kinds of ideas that have not been adapted market-wise. Colors was a disaster cost-wise. It was not adopted anywhere else. They could have gone with much simpler or better solutions for the direct detect. COBO was dead on arrival, and now CPO, along with COBO, suppliers have to use resources, devote resources to unnecessarily, in my opinion, in order to, because they're afraid that they'll lose Microsoft's business. It isn't bad enough that the web scale operators are driving components down at commoditization levels. And if you look at the two biggest component suppliers, Lumenum and II-VI, what they're doing in an increasingly mature market, I would say a market that's matured a long time ago, especially datacom and telecom, they're picking and choosing. They're going to different sectors. They're picking exactly where they want to go on the food chain and going for the best options possible. Where's the money going to come from? To do all this stuff, we'll be lucky to have 400 gigabit Ethernet components in 2026, let's say 1 million of them, given the virus and everything. So I know that's an open-ended statement, a bit of a rant that I'm known for. So
it is not. I actually think that you hit the right spot. And for me, the key question that I have here is that I see many parts of the supply chain not fully understanding what co-packaged optics actually is. But I'm going to give the floor to Jim. Jim, you would like to comment on Mark's statement?
I would love to, because I'd like to answer your question, actually, Jose. What is co-packaged optics? So first of all, to comment on Mark's take, false starts are part of the creative process. So if you're not failing fast, then you're not trying enough things. But so I'd like to highlight what co-packaged optics really is or what it's trying to solve. So no matter how a hyperscale or a data center architects their switch architecture, no matter which architecture there picks, there will always be at least one stage somewhere where everything must touch everything. I call it the fan out. but in a three-stage clone network, it's the middle stage. But no matter what hyperscale data center you look at some point in that architecture, every port must touch every other port. And that drives a lot of power. Remember Brad Booth talking about they're really power concerned with power. It drives a lot of cost. It drives a lot of volume, a lot of interconnect. So CPO is the attempt to say, you know, for this one part of my switch network architecture that is so demanding in power, cost, and interconnect, maybe I can leverage technology to solve that one headache. So they're trying to solve that one little piece. It may be COBO, it may be co-packaged, it may just, I actually saw one data center company use a PON, use an actual access PON because they could hit 64 ports with one architecture. So I've seen every solution you can think of, and I just think all the smart people in our industry can put their heads together, and we can find a way of solving that. And when I saw a lot of the technologies in EPIC, I'm like, wow, all of this, just like the one we just saw, that can solve the problem. And I know we're still going to see Cisco, so we can ask Cisco about it because they're leading solving this problem. But I think we can bring a lot of these technologies to bear to solve what is their number one headache. What do I do on my fan out of my network?
Patience is not my strength. I cannot wait. Brian, thank you very much for joining today. Thank you for joining from Cisco. What do you think of this debate? Are we considering co-packaged optics as an intermediate point? How do you feel about this?
Yeah, so I don't really view it as an intermediate point for the reason being that already within the switch, people are going to MCMs just for copper I/O. You know, they run a reticle size, they want to utilize it all for logic. So, you know, even, you know, like a 50T switch, if you were doing it all copper, for instance, you'd have one or maybe two switch dies surrounded by SerDes tiles. So, you know, co-package to me basically means you've got an MCM, but instead of electrical SerDes tiles, you got optical SerDes tiles. And it's difficult to see what in the CMOS world would reverse that trend. You know, unless you went to dramatically larger reticles with dramatically lower defect-driven or density-driven defectivity rates, you're probably going to stay on an MCM style for the high density, high throughput host applications for, you know, as far as I can imagine.
This is all a semicon technology. So at the end of the day, it all goes down to try to optimize whatever we can do in a CMOS plant. Is that right, Brian?
That's certainly our view. I mean, we've you know, we've long tried to make our optics as CMOS-like as possible, so that, you know, as you're trying to do this multi-chip integration or single chip integration, you know, it's a common technology base and common packaging techniques.
This is exactly my vision. That's why for a meeting like this, I need to have a semiconductor company in the room. For me, I really need to understand how they see the integration of optics in a semicon process. Is this technology really a semicon technology? And for this, we had the next speaker, actually. We have Vincent from ASC Group. Thank you very much for joining this very interesting meeting. We are broadcasting live in YouTube and we're making very interesting statements. Vincent, the floor and the attention of everyone is yours. Are we talking of a semicon technology?
Yes, exactly. Yeah, we are going to share some of the experience of the.
It is coming. It is here.
Okay. Again, thank you, Jose, and all the EPIC member. Good day. I'm Vincent Lin from ASC Group, and my today's topic is something about packaging, spatial packaging of the silicon photonic. And I would like to share some of our development status and some of the challenges we actually faced. Okay. So ASC actually is the world-leading electronic packaging company. So our portfolio including the IC packaging testing, and we also have USI. So we have SIP module level and also some system integration capability. So we can say ASC actually is the world, maybe only one who can bridge the IC OSAT and the EMS world. So we already established more than 30 plus years. Right now, worldwide have 100K employee with 90 facility in worldwide. 2020 revenue already reached $30 billion US. Okay, lastly is the topic I want to bring today is some overview of the switch optic integration evolution and some of the typical SiPho packaging structure, and also show some the challenge we face of the co-packaging, and how we plan to consolidate the supply chain and for the further cost reduction. I think everyone is very familiar with this slides of the data center switching, maybe tier 1 or tier 2, and how to integrate with optics. Right now, of the 12.8 T switch, we still use the front panel with pluggable optics with long distance between switch and optics. Eventually, when the speed higher and higher, that will go COBO or use the same packaging to packaging the same substrate to packaging switch and optic together. Most people believe that will need a speed higher than 50 T switch. So those kind of a better configuration that will got a higher bandwidth, lower power. If the industry, the semiconductor industry can deal with the better yield, that could reduce the cost significantly. This slide shows the typical SiPho engine packaging we understand. Typically, we have the PIC, EIC, laser, and the fiber, and they'll have a different kind of component. By using some of advanced IC packaging technology, for example, EIC, PIC actually need a very short distance interconnection, so that we can provide the chip-on-chip copper pillar interconnection. And laser actually, they still have a different kind of options. For example, embedded, or AC also can provide the we call first level wafer scale laser packaging, maybe hermetically. And module level or the fiber, they have a different kind of coupling way by grating or by butt coupling, by active or passive. Eventually, advanced packaging will significantly shrink the size to let the SiPho engine become small and compact and easy to put together with the switch in the same substrate. The substrate is still in pretty big size, for example, larger than 100 millimeter by 100 millimeter. So we actually still have a lot of a challenge of this kind of switch IC optical packaging. For example, because the size of the substrate is huge, so the voltage and the reliability is still some challenge. And for the switch IC itself, it probably is not a kind of a single chip, but a multi-chip. So we also need a kind of very high density fan-out or interposer layer to provide a very high density die-to-die interconnection with a very narrow interconnection pitch, very fine line RDL, and still need a lot of layer count. Thermal is still a kind of problem. It's not including the optics. For this kind of switch, the power will be start from 400, 600 watts. We even heard some number is 1,000 watt. Optical engine, that's still the key portion. They'll still have, we call one device, one packaging, one product. So everyone choose different kind of a packaging configuration of the optical engine. Size per data rate is the key. And also how to do the fiber attach is in the interleave or in the final step, how to deal with the small budget of the fiber and the optics. I think that all is still a kind of unresolved issue. The other point is we face is the supply chain right now is still pretty fragmented. Design house, PIC, EIC manufacturer, how to do the PIC, EIC integration, optical assembly testing, and the final module assembly. Typically, all the supplier in not the same house. So AEC plan to start with what we have is PIC, EIC integration, and step by step to kind of incremental with optical assembly, with final assembly. So we provide the toolbox like the following. The first is post PIC or CMOS process. The black one is what we already have. It's typically post IEC bumping process. But we also can provide a very specific for optical packaging. For example, special metal, like gold, like gold tin, ARC coating, and some special micro machining process post the CMOS. And we also have the wafer level assembly, COC or COW assembly, wafer level assembly, and we also invest some high accurate laser attachment tool, and start with optical component placement. Wafer level testing, I think that is the key. We already have a lot of electrical testing, but step by step, we will have some wafer level optical testing. Module assembly, we have a standard SMT, and also evaluate some different kind of fiber attach approach. Final optical module testing. And the AC also provides the multidiscipline, multi-physics, simulation, calculation. We have a very strong lab service to support this kind of different kind of domain integration. So, by this kind of toolbox preparation, we believe that will consolidate the supply chain and also provide the significant cost reduction plan. That's pretty much I have. Thank you. So, any question?
Thank you very much, Vincent. A great presentation. Okay, and what about the EPIC challenge? I mean, the EPIC question. What can you do for them, and what can them do for you? What will you say to that?
Right. So AC already engaged a couple of very key customers of the silicon photonic, including the startup company, including the data center owner, and also the switch IC player. So as I mentioned, we try to consolidate the supply chain. So far, it's still fragmented, and start what we have now, and kind of a step by step have a specific toolbox for optics. So last is what can we provide for this kind of a society.
Okay, thank you. Mark, I think you have a comment.
Just a quick question for Vincent. Would you, I think there's a 50-50 chance, even a little past 100 terabits, we could get away with a pluggable. Do you think I'm crazy? I know we have to do some adjustments, but I think they're minor to get to a pluggable. Or are you confident we'll get the CPO when we get past 100 terabits? Thank you.
So I think your question is when can we start with from a kind of a paradigm shift from pluggable to COBO to co-packaging. We heard some voice from customers. They will kind of mix the use those kind of a configuration that reflect in one switch box. They'll have a pluggable. They will also have some co-packaging. So I think that is a mixed mode.
Okay, and I think we have a question from Giovanni. Giovanni, would you like to make the question by yourself? I'm going to unmute you. Okay, now.
Okay, yeah, sure. Thank you. Well, the question was related to the wafer level test, and the question was basically if is performed cassette to cassette, so it's a pretty much automatic way, and more especially if the test is optical, electro-optical, and simultaneous electro-optical test.
All right, the wafer level optical testing. Right now is a kind of sorting procedure. So when we got the PIC wafer, we need to have a kind of make sure that is a non-good PIC unit. So let's use so even the device itself is use buck coupler. So they will still have some grating coupling channel. So we can use the optical fiber to detect the signal. Maybe have a light source in and the light source out, and also probing some electrical performance. So I believe that will be OC. That will be PIC foundry kind of standard. We know some of the company, including ACE, they already have this kind of wafer level optical testing for PIC non-good die sorting.
Vincent, I have really big memory. And in 2013, I was in Porto at a semi-meeting in which ASC presented the roadmap for 3D integration, and they said that the future was BiCMOS technology. Is that something that we see as a future solution to integrating electronics and photonics at the same wafer?
We do packaging integration, packaging interconnection. So I think the BiCMOS, both PIC, EIC integrate in the same wafer, probably is another AEC expertise. Yeah.
Martin from EVG.
Hello. Yeah, I also have a question to you, Vincent. Very nice presentation. Thank you. I'm wondering, and learned a lot throughout the day, very good presentations, but still I see in this packaging you're addressing, there is still a lot on die level. So I'm wondering, are there any requirements that we can keep up the wafer level manufacturing longer? We have a lot of questions on that for heterogeneous integration to smear out die level, wafer level a bit more, that you can keep longer this platform to integrate obviously the wafer level optics. However, I don't see it really happening as a requirement. Maybe the volumes are not high enough, or how do you see that topic?
So I'm familiar with the EV group and what EV group can do. You can do wafer to wafer bonding, even chip to wafer bonding. If you are asking do we have any plan to kind of a direct bonding laser to wafer? I will say some IDM, they have this kind of capability. That definitely need a kind of in-house to deal with heterogeneous material integration, including, for example, gallium nitride or other laser material. Yeah, please go ahead. Yeah.
Exactly. This is one of the topics. However, I would see it a little bit broader. So it's generally a question: what for the photonics, there are two different platforms coming together. What should be done on wafer level? What is necessarily to be on die level? Or is there more room in between wafer level and die level than in other technologies?
For AAC or our viewpoint, we will choose, for example, start with die level, then is a chip on wafer. Mm-hmm. And finally, wafer to wafer probably is a kind of not the OC favor. Yeah.
Understood. Thank you.
Yeah. Thank you.
Okay, so thank you very much for this interesting discussion. So, well, we have a special guest that just joined, Rob Stone from Facebook. Thank you very much for joining.
Hi there. Good morning.
Hello, Rob. So, well, would you like to comment about the work that Facebook is doing in package optics, and what are your main interests? And well, you also have here all the supply chain in photonics, so maybe we can help you.
Yeah, sure. So, I mean, as many of you may know, I only recently joined Facebook, so I'm kind of in learning mode about what the team's doing here. But I think it's also probably common knowledge that between Facebook and Microsoft, the two companies have released some specification guidelines specifically on co-packaged optics. There's a series of 3 documents which are on the JDF website associated with this. So I think rather than me, restate that, I would point people to that website, for the guidance specifically on the challenges and the direction that jointly Facebook and Microsoft would like to see the industry take relative to this field.
Okay, thank you very much, Rob. We will come back to you later for sure. Okay, so let's move ahead in the program. Let's go to the next speaker. That is Gabrie Hoogland from SABIC. Very good, Gabrie. I can see you are now. If you can put the presentation mode. Okay, perfect. So can we hear you? We cannot hear you yet. Check if you are mute.
Yeah, I thought you would mute me.
No, please, go ahead.
Thank you, Anna. Thanks for the opportunity to explain SABIC as a company to you and how we can help in the field of CPO with our thermoplastic resins. SABIC is the 3rd largest chemical company in the world. We have several business units. The one we focus today is the specialty BU. In this BU, we produce highly differentiated polymers with focus on fast-growing and disruptive end markets, smart electronics, autonomous driving, renewable energy, and obviously also co-packaged optics. Significant portfolio we offer is our so-called thermo-optical portfolio, resin. This is a wide range of plastics that can be injection molded in an optical element like a lens or even a lens array to couple light from fiber to detector or from VCSEL to fiber. And we differentiate ourselves from other injection molding optical plastics, mainly by focusing on 2 key attributes. A very high refractive index, but more importantly, also a very high heat resistance, especially to be able to withstand typical assembly processes like surface mounting or reflow soldering. So in the table, you can see that we have 2 distinct classes of, Two distinct classes of plastics. On one hand, we have the water clear high heat polycarbonates called Lextan with glass transition temperatures up to 200 degrees Celsius. So these are typically used for what I call cold reflow soldering. But the topic of today is more the polyether imide resins like Ultem and Extem with glass transition temperatures all the way up to 270. that is suitable for typical GDAC type of reflow profiles with peak temperatures up to 260. For all these reasons, we have full data sets of optical properties. And recently, we added them in the CMAX Optics Studio software for optical designers. And I would say the big advantage of these unique thermoplastics versus other, let's say, non-plastic materials like glass is the fact that you can micro-injection mold the lenses in any shape or form in refractive optical elements, but also in diffractive optical elements with very fine surface texture. On this page, I'd like to show you 3 different applications in the photonics industry where these materials are being used or can be used. First of all, Axtem is widely used in optical proximeter sensor lenses, especially in mobile phones. And our customers appreciate here the possibility to produce freeform optics on a large scale, which means with only 4 molding machines, they can easily produce tens of million lenses in just a few months. The second example on this page is well known to you. These are the lenses used in a pluggable optical transceiver, which I guess everyone knows are mostly made from ultem resin. And the reason why they use ultem here, both on the TOSA and the ROSA side, is really the fact that the thermal expansion coefficient is extremely low, so it gives you good dimensional stability at a wide temperature range. Next to that, you can also not only mold the lens, but you can also mold the fixture in one shot for easy alignment of the light. And then finally, and you see that picture on the right, that's the topic of today. That's where we hope we can position our material as well, the onboard optics or co-packaged optics, where you can see in the picture that these Axtem lens arrays can be used potentially as interconnects. So the big advantage here that the connector survives reflow soldering and might be an alternative to so-called other ways of light coupling, which I think I already heard the last 1.5 hours, where you might have open connections which are sensitive to dust and other contamination and might result in significant signal loss. So to the audience on the phone, I would like you to be aware of this possibility when you consider the design of a co-packaged optics modules, that at SABIC we have many contacts with global micromolders that can actually work with you on cutting tools for these onboard modules. Actually, one example of that micromolder is Nailux from Japan that works with us to cut a tool for a big OEM in the semiconductor industry that wants to position a multi-mode onboard connector in the market next year to couple light from the, let's say, from the fiber into the die and then backwards from the VCSEL to the fiber. So here are, let's say, 16 different Axtem lenses molded in a connector of roughly 9 by 4 millimeter. These parts we just molded a few months ago. We have done some reflow soldering tests and we looked at 2 things. We looked at dimensional changes after reflow soldering, and we found that the delta in dimensions are very, very small, 0.1, 0.2 micron, which is more than good enough for multi-mode optics. But we also looked at signal loss in dB. Because of these Axtem lenses, I think the signal loss, well, I wouldn't say it's negligible, but it's a very low amount of signal loss, 0.2, 0.3 dB. So that looks all very promising. So once more, we like to work with more partners that work in the space of co-packaged optics. And well, what SABIC can offer you is, you can see on this page, we have a full optical data of all our resins, refractive index as function of wavelength or a temperature. We have optical constants loaded in the ZMAX. We have options to use reflective coatings when customers would like to do that continue to stick on the substrate also after soldering. And we have a center of excellence here in the Netherlands with a broad range of equipment where we can do our own reflow experiments. We have a confocal microscope to look at dimensional stability. In the summer, we're going to have a new micromolding machine from Arbor So again, by this closing remark, I would like to invite you to visit us, to witness those capabilities, and contact me for further questions. With that, thanks. Back to Anna.
Thank you. Well, Gabrie, I have been there to the facilities, and it's actually quite outstanding. It's amazing to have SABIC, a huge player in the petrochemical industry, also enabling the CPO, enabling the onboard optics. And I know you have been, that's why I put you in the agenda now. You have been working with many semiconductor manufacturers. I think it's actually quite public, your work with ST Microelectronics. The question that was raised before is about the cost or is about the losses. When it comes to cost, is the onboard optics for you a huge challenge?
Well, that's a good question, of course. I mean, the resin price is higher than standard polymers, but obviously we should think in part price, right? So it is really, the cost is mainly in the ratio between the part and the sprues and the runners. So some molders are able to produce one part with only 1 gram of screws and runners, which makes the price of an onboard connector, well, 5 cents max. Other molders do need bigger runners and bigger sprues. And then, of course, the yields go down, and then the price can go up to 10 to 20 cents. But these are the typical price ranges that you should think about extra price.
When it comes to reliability and when it comes to long-term stability, of course, this is the solution to have, and is the price to pay. We have a question for you from Fraunhofer HHI. Martin Schell, what's your question?
Thank you very much. Very interesting presentation. Do you also do waveguides from your material? And if yes, what are the dB per centimeter?
Yeah, it's a good question. No, we don't have resins with a very high delta in refractive index. So I think we tried it a few years ago, but it's something that we leave to other companies. So we really focus on the lenses and the optical elements.
Okay, thank you.
Thank you very much. And also we have today in the room a company that I've been seeking already for a few years. People know that Applied Materials is one of these key companies who connects the photonic industry and the semiconductor industry. I think we have from Applied Materials today our new friend Shiva. Thank you very much for joining today. What did you join a meeting like this one, and what kind of cooperations would you like to start afterwards?
Thank you, Jose. This is Shiva Rai from Applied Materials. Applied Materials, I mean, everybody knows Applied Materials in the industry, and we are trying to focus a little more on technologies like silicon photonics. Trying to understand not just from the wafer fab, but also from the packaging side that drives newer stacks and newer architectures to make co-packaging technologies available to the industry. So my effort is to understand, what are these newer architectures bringing in terms of challenges to the wafer processing and wafer level packaging, and how would Applied partner with companies to enable some of these newer developments on the packaging side.
Having Applied Materials in the photonic integrated circuit community, in the silicon photonics and indium phosphide communities, it is priceless. So welcome to the EPIC family. And I'm going to present you to some of the people who you are going to work together in the future. And I have Axetris all the way from beautiful Switzerland in the room. How did you find the meeting so far, and what kind of cooperations, introductions are you going to ask for me to do afterwards?
I mean, this is
sorry. Okay, let's go Shiva first, and then we go to Myung. Shiva.
I'm sorry. So yeah, this is a great opportunity, for me to, get used to, and learn all the challenges that are being worked on, and definitely would love to learn how these requirements are going to drive the process requirements that someone like Applied Materials could address.
Thank you very much. We're going to have soon a meeting in which I want you to have a presentation. I'm going to contact you about this. But Myung from Axetris in Switzerland, this meeting so far, what kind of cooperations would you like to start right after?
Thank you, Jose, and thank you, Anna, for organizing this meeting. So, as you excitingly advertised, we are very good in the micro-optics. Yes, So we are expert in microoptics, but here in the co-packaged and integrated photonics, we are looking for something more, because we can do by our MEMS foundry services, we can do something more like mechanical features or metal pads for electrical connections, or also the soldering. So assembly or integration point of view, we want to have more collaboration with the consortium members in COBO or integrated photonics modules. So that's what we can offer. And so what we want to hear from you more about nothing more than optics, but other things like mechanical features or electrical connections as well, so which we can support for you.
From a microoptics manufacturer point of view, do you feel that you're getting enough information from the, let's say, the COBO partners or the CPO industry in general to design your microoptics to their specifications?
Yes or no, because we have established connections with our customers who is partially involved in those consortiums. So we have some informations, but we are not fully integrated in the standardizations or like specification settings. So this is the motivation to join this meeting, to establish more contacts and more informations, more involvement in this consortium.
I mean, like in the more, in the best passenger seat ever. So from my passenger seat, I can tell you that there is not enough information. We need to increase the amount of information being shared. I'm going to go to one of the key companies in manufacturing optics or glass in the world, SCHOTT. I'm going to go to Tobias Kochke. Thank you very much for joining and represent SCHOTT at this meeting on CPO and co-packaged optics. What kind of cooperation so far you think we can make after this meeting? Tobias, we have you muted. You need to unmute so we can hear you. Yes. Tobias, I still cannot hear you, so I may come back to you in the next Q&A. So I think now? Yes, now.
Now it works, sorry. Yeah, thanks a lot for your introduction, and also thanks for organizing this nice meeting. SCHOTT already has long history also in wafer level optics, and my part is a bit different. I'm joining SCHOTT now for 1 year, and I'm looking more into the semiconductor part. And I would like to understand at the moment, where is the industry standing in terms of integration of optical communication, especially inside of the PCBs. So I think the presentation from vario-optics was very interesting for me to see that there is already some products available, but I also see that at the moment the end customers are missing. At least this is what I also understood out of the discussions here. So this would be for me interesting to get more context in this direction, to understand if there is any need also to introduce the co-packaging into the PCB and also introducing glass PCBs in this market, or is there any blocking points at the moment from the technology side which hinder the overall?
All this is planned. It looks like it's random, then just asking you question, but all this is planned because I wanted to get exactly what you just told me to introduce Brian. Brian, you see, we don't have enough information. Cisco can lead the way on this. Cisco can tell us what kind of optics we need for the co-packaged optics. It's great to have you, Brian, here with us. The floor and the attention of everyone goes to the giant Cisco.
Thank you. It's no pressure there. Let's see if I got
no pressure at all.
So yes, so thank you very much for having me. So prior to Luxtera, I was part of Luxtera team that came in through the acquisition. So, you know, co-packaged optics, integrated optics, whatever you want to call it, is something that we've thought of for quite some time. And, you know, even in the conventional optics space, we've always tried to pursue the technology with a view towards, you know, future integration deeper into the system. Our general approach, and a version of this was shown earlier, but our general approach is to, you know, make the optical technology behave as much like just a pure electrical technology in every way possible in terms of how it's manufactured at the silicon level, in terms of where it's manufactured, again, using the high volume CMOS foundries, test strategy, getting very good wafer scale test coverage electrically and optically, and integration. And what you see here is a integration exercise. In the middle, you see an MCM, which aside from the fibers coming out of the side, could be, we hope, looks not that different from just an electrical MCM. So at the heart of it, you'd have a switch die, or maybe several, surrounded by SerDes tiles. So, I mentioned previously in a question and answer that people today are using SerDes tiles for electrical AO. Here, the difference is use them for optical AO. One of the things that, maybe doesn't jump out immediately from this, but is sort of our intent here is, we try to push the tile density as high as, not as high as we can, but reasonably high. That brings benefits in terms of cost and performance of the tile itself, but really what we're trying to do there is minimize the number of optical attaches. Because as you go through the assembly flow, that is one thing that is done sequentially. An optical attach, they can be high yielding, but they're not perfect. So the more sequential steps you have with some yield fallout, the worse the net yield would be. So this concept here, which was a 51T switch, we're targeting 4 tiles at 12.8 T, mostly to keep us to 4 optical attaches. And it's hard to see, if you look in, but basically these black, you see all the fiber harnesses coming into the IC, and you see kind of 4 black aggregation points. Those connect into the, if you look really close, let me see if I have a laser pointer here available. Don't remember how to do that. Well, if you look really close, kind of below the blue arrow, you can kind of see the fiber interface to the IC, and that's a single attachment and a single bond. One of the things I think I should correct, I think earlier it was suggested that these use edge coupling. They don't, it's actually vertical surface coupling. And that's something we've used for quite a while, primarily because of its manufacturing benefits. It, allows you to get full wafer scale testability of your IO. It also provides a very good large surface area to bond to when you're coming in with a coupler. As we look to push higher and higher density, it allows you actually to scale in 2 dimensions too, if you're trying to get more fibers into a tight footprint. Surrounding the MCM, there's really 2 additional elements. So the fiber harness takes you to 2 locations, takes you to the faceplate, and it takes you to your light sources. The remote light source for us is important because one of the things we want to do in an MCM is have a uniform thermal environment. You don't see it here, it's removed, but there's a common lid and a common heat sink. We're not trying to segregate out the optics from the switch. They're all expected to run hot. But to do that, we need to get the laser out of there, because laser efficiency and reliability drops off quite dramatically with temperature. In this design, we have them in a QSFP form factor. That's a form factor of convenience. It doesn't have to be that, it could be anything. It's really just a collection of CWDM lasers packaged up with a control interface for some diagnostics. As we look at the key components, there's lots of nuance to this for sure. But on the silicon photonics, we want a technology that allows us to do very dense integration, both lots of lanes inside of the tiles themselves, but also getting it very close to the host IC. One of the big reasons to pursue co-packaged optics is to eliminate the power consumption inherent in electrical SerDes from a switch to an optical tile, for instance. And to do that, you want to get them really close together. But it also needs to be able to tolerate high temperatures. The switch, you cannot keep a switch you cannot cool it to the temperatures historically we needed to cool optics to, which means you need to get the optics field to run as hot as that if you want to integrate. You know, I know there has been some investigation to creating segregated thermal environments, and there might be some merit in that. But even still, trying to create, you know, trying to get something like a 70-degree optics into that package and maintain that environment is would be very difficult ambition to realize. On the light source, we want it efficient. You know, we want to be able to push as many lanes per laser as possible. This is something we've done for quite a while in parallel single mode optics, you know, and as technologies improve, the amount of throughput per laser has increased from 100 gig to 400 gig and hopefully beyond. It's going to vary depending on the application. You know, purely parallel optics may see more than, for instance, multi-wavelength optics. If for no other reason, the multi-wavelength optics, you have the additional losses of mux demux somewhere in the path. Reliability is very important too. It needs to be actually considerably better in pluggable optics because while light sources can be serviceable, you know, people will approach co-packaged optics with a certain apprehensive. Some end users will be very bullish about it and they'll be willing to take risks. But the broader market, you know, they take the risks when they're absolutely necessary. So, you know, if you come in with a solution that doesn't show it's really reliable, you're not going to have to touch it, you know, the fact that you can't replace optics anymore isn't a concern. It might give them pause. You know, on the light source, I mentioned temperature above. You know, remote laser kind of takes care of that. You'll have a unique thermal environment for the laser. You're going to have nothing else heating up other than itself. Alternatively, if you were to go the integrated laser approach, you'd need something thermally insensitive. It's not the approach we're pursuing, you know, but it's, you know, it would be one possibility. In terms of the interfaces, the electrical I/O, you know, 112 gig XSR seems to be the most common choice out there. Certainly, if you look at the switch silicon ecosystem, that seems what people are focused on, and you know, it'll work reasonably well. It's pretty power efficient. You know, I've heard numbers in the 1 to 1.5 picojoule per bit range. Definitely offers pretty compelling power benefits versus, you know, like a VSR style SerDes, as is typical for chip to module interconnects. On the optical I/O, the big thing is going to be that it complied to some standard. You know, most likely 400 gig DR4 or FR4. You know, there might be faster ones coming. But, you know, as this gets deployed, it's going to be deployed, you know, it's not going to be deployed everywhere all at once. It's going to have to interop with legacy equipment, with lower density switches, for instance, that use pluggable optics. You know, it needs to operate as part of sort of the broader DC ecosystem. And that is all I had.
Okay, thank you very much, Brian. Great presentation. And well, let me to ask you the question: what these companies can do for Cisco, for you?
You know, to be honest, it's not a question I've thought about before getting on here. I mean, the one thing that I personally worry most about, you know, for co-packaged optics is if everyone goes off and chases their own interface standards, you know, proprietary optical PMDs or some specialty electrical interface, you could very easily end up with an ecosystem where no two parts talk to one another. And I think that's going to be bad for the players in the ecosystem. It's also going to be bad for the end users because, you know, no matter how compelling an option, a solution may be, you know, they always want some degree of multi-source. You know, they'll want to be able to entertain multiple different silicon providers, multiple different optical providers, multiple different people managing package and switch integration. So I think keeping that in mind as all of us progress will be very valuable if we want to see this stuff deploy soon.
Okay, thank you. Then I think we have a question from Jim from HG. Jim, if you want to ask your question.
All right, thank you. Well, I think he partially already answered it. So he mentioned his preference right now is the XSR electrical interface. So my question was earlier before it was your turn when Jose couldn't wait to talk to you. And I'm glad he didn't. You mentioned that you're taking, you look at these modern switch ICs and they're just ringed with these SerDes and they suck all the power and they suck all your die area and it ain't cheap at 7 nanometers or less. So you talked about those, on those MCM modules, those SerDes going away, now being optical chiplets instead. But a lot of the implementations I've personally been privy to so far have still had the SerDes there. And I think it's just because it takes a huge effort to get a custom switch made if you want to get rid of those SerDes. But I guess my general question to you is, how much of the SerDes really goes away when you're driving the chiplets? Because you still have to do PAM4, you still have to do framing up. There's still a lot of stuff being written into IEEE interfaces, because you mentioned it's got to be a standard interface so everyone can talk to everyone. There's a lot of stuff written into there that is still going to require the SerDes. So how much SerDes really goes away when you replace that, when you put the optics right on there?
I mean, the biggest difference, if you look at pretty much any PAM4 SerDes that's, like 100 gig PAM4 SerDes that's meant to go across the PCBA, they're very equalizer heavy specifications. They almost exclusively drive ADC plus DSP based implementations to make the channel work. And those drive a lot of power. They drive a lot of area too, but they especially drive a lot of power. So as you go to an XSR, you go to a very simple, very simple analog style interface. It's still PAM4, but it has minimal equalization requirement, not one that you need to go to the digital link to solve. So that's where most of the power savings comes from. You still have, the higher level MAC, PEC, FEC. They're still there because those are used for the optical links as well. But the continuing trend in electrical I/O has been to just throw more and more equalization into links, and it's a trend that's going to just, I don't know if it's going to break things, but it's getting so much harder to manage that with each generation. You're going to reach a point that it's no longer worth it.
All right, awesome, thank you.
Okay, and I think Jose has a question from the YouTube universe.
From the YouTube universe, I love when you say it like that. Oh, question from Canada, from a company called Ionics. Francois is the CEO. So the CEO of Ionics, Francois Menard, do you see co-packaged optics go the route of CWDM4 or CWDM8?
Well, I think it'll go the route of, it'll always want to be a standard interface that's interoperable with a pluggable solution. So insofar as there are numerous standards based around CWDM4, and I don't know if there's any, well, I'm not gonna say, that's probably unfair. There's only not any IEEE standards I'm aware of around CWDM8. I think CWDM4 is probably a more likely candidate. But if there were to be standards that utilize CWDM8, it could be a viable candidate as well.
All right, I want to ask something else from my side. It is a very important question for me. So basically Cisco acquired Luxtera. Now, I don't know if eventually we'll finish with the Acacia thing. It looks Silicon Photonics is the driver of a future of transceiver in the vision of Cisco. We have seen a huge development on indium phosphide platforms for the future of integrating the laser into the same epitaxy as the photonic integrated circuits. And actually, this would solve some of your challenges in your slide. Is there a vision towards photonic integration with only indium phosphide without silicon?
That's not a vision I've had. Cisco is a very large company with a lot of very smart people in it. So, it wouldn't surprise me if someone had that vision. But, my focus is mostly on the silicon photonics.
We have a great community in Europe on the indium phosphide integration with success stories like Effect Photonics or Infinera, but Fraunhofer HHA has been driving the foundry service of this. Martin, what can we tell Brian about indium phosphide added value to the next generation transceivers?
Yeah, potential added value would be, of course, the integration of a laser into the circuit, but to be honest, when the operating temperature is 105 degrees, this is a very tough challenge. And as I roughly estimate that there is already 64 fibers going in and out of this module, another 2 fibers or 1 fiber for the laser doesn't really drive up the cost significantly. So in this special case, I don't feel too happy to say, but I would probably silicon photonics is a better solution than they can do it.
That's great. I mean, at the end of the day, silicon photonics cannot integrate a laser, and the best 3-5 material for the lasers in datacom wavelength is indium phosphide. So it's business for everyone. I think I would like to introduce you to a company all the way from Icon Photonics, a company packaging pixels at wafer level. Carlos, thank you very much for joining today. What would you like to do with Cisco? I have you muted still. Yes.
Can you hear me?
Yeah.
Hi, Jose. Thank you very much for this opportunity to talk a bit about Icon Photonics. Is a technological startup spin-off from a CNRS research center in Paris, east of Paris, in France. And what we do is to bring collective manufacturing using micro fabrication process to the photonics packaging issues. Basically, our vision is to bring the first step to bring optics to the chip. So we do on-chip 3D polymer micro-optics technology directly at the aperture level of the chip. So before dicing at the wafer level, we use a lithography process to do that. So it's really a collective manufacturing process. And then we using this polymer layer, we can go to the next step, which is, for instance, wafer bonding, bringing a silicon feature using wafer bonding, where we can have these V grooves to bring the fiber into these optics. So basically, we do everything. Our vision is to do collective manufacturing at the wafer level, because at the end of the day, you need to think about cost-effective solutions. For sure, high performance, reliable, but at the end of the day, also collective cost-effective solutions. So thank you. Back to you, Jose.
Well, yes, back to me. Thank you very much, Carlos. Great presentation of your company. If someone in the Zoom room wants to connect with Carlos, please send me an email and I will make the introduction and you can know more about this technology. Okay, so let's move ahead in the program. So next speaker is Ruth Houbertz, CEO from Multiphoton Optics. So Ruth, if you want to share your screen.
Hopefully. So you see it?
Yes, very, very well. We can see it. And if you can go to presentation mode.
Oh, yes, I try. Ah, yeah, here we are.
Okay, very good. So
okay,
you can
if
start.
it's not moving, just tell me.
No, it's perfect. Yes, you can start.
Today I give all my heart blood because I see something happening which I'm dreaming of for like 20 years now. It's about changing the paradigms and using 3D lithography for datacom or telecom, or it doesn't matter, packaging. And it started many, many years ago. And I just show you the history of what we did. Started when I came back from the US with wafer scale optics. So this is for actually telecom application, was awarded in 2002. Cooperation with Thales and IOF in Jena. Then we did some waveguides already in 2002 with TPA writing, like direct lithography. 2004 to 2008, we did works with UANEM Research and also AT&S company to do an electro-optical board, which is actually shown here. So having 6 waveguides, and that was at that time 42 gigabits per second. We continued with doing multi-mode waveguides. So this is a cross-section of a collaboration I did with Fujitsu Siemens in USA on a printed circuit board. So here you see the waveguides and that what they created as package. Switch to TPA and direct laser writing again, coming from single mode to multi-mode waveguides in polymer-like materials. Collaboration with Christian Koh's group, KIT, 2013, 2014, showing adiabatic coupling of waveguides, and all these works were presented at conferences. So this one was presented in 2014 at Photonics West. 2016, using microcollimator concept together with Gianni Preve from CNIT and Mark Shaw from from ST Microelectronics to bend the light just around the corner. And that is a example of our collaboration partner and production partner, NanoPlus. That is a edge laser with a little lens on top of it. And when you see that is, I started very early to create a vision. And this vision, people thought we are completely nuts, but I dreamed of creating optical packages which can be assembled just like electronic components. And it started very early. And here at that point in 2006-07, I started to think about spinning out a company, which we did in 2013, 2014. So here, so you see, there was quite some years. There was no market. People did not understand what we do and so on and so on. But what we think is we are all there to create that. And why do we think that? So here's an example of what is the typical legacy processes, and this has been published a lot. And what we did in 2006-07 together with AT&S in Austria was just direct writing the waveguides, and the printed circuit board, which we did there, had 12 centimeter waveguides, and you still can see them. So they traveled a lot through all the exhibitions, and I found a company who is willing to share their equipment to determine whether they are still alive. So we doubt it because everybody touched it and we showed it around, and it's now like 13 years around, but you still see the waveguides very, very clear. And the process we just used is like 3-step processes, and we also use intrinsic processes of the entire production line in the company. So that was awarded a lot. So I received the Fraunhofer Award. We received the Green Photonics Award. So this has to be 2013. And then in 2014, we were awarded again for that. So what did we do? And I just show you, hopefully that runs, is we actually can orchestrate the beam by direct laser writing, as you see here in this animation. So you see here a waveguide, which is completely a weird transformation, but you see them, you go up and then you can turn it, basically being capable of touching and of connecting almost everything with our machine. And that's the reason why we are a hardware supplier at first, but we do lots of applications with our customers. So the idea was here is the original of a grading coupler, and what we did is we made it pluggable to some extent here, and that is just an image I borrowed from Intel, but it's all about the cost, the time, the flexibility. So what we strongly believe is that we can be very, very flexible, very, very fast. We simplify the processes to get rid of most of the interfaces. So that was done in this approach as well, so that you basically can get rid of sources for failure and so on. And this process can be ideally automated, and also fiber handling is an issue. And Torsten Vahrenkamp from Ficontec pointed that out today, but there are ways in our machine to handle that. And that is, I think, all I would like to show you, except for the examples like wafer scale, edge emitting coupling, then the VCSEL coupling, LED coupling, and so on and so on. So whatever you think is possible can be done, and it can be integrated to a very, very, very high extent. And that is very important to us. And we are looking for companies. So we are now started to open for strategic, very strategic partners and strategic investment, because now is the time to move on. And that's the partners and the publications which are related to all these works I've shown you so far. So thank you very much.
Thank you very much, Ruth. So, well, can you tell us more about these strategic partners that you are trying to get, and what kind of companies?
Yeah, so ideally they have what we do not have. So what we do not have is packaging. We do not have all the infrastructure. which comes along with this type of packaging. So we are just a slice in this entire value chain. So, but we have proven over the last 20 years that all these things can be connected, can be miniaturized, can be used by very, very, let's say, smart materials coupled with smart production is a very, very powerful tool, but we're just the slice. So we need to stretch our arms out now, because now is the time to get that done. And I'm very excited about today's meeting, actually. It's really, I'm burning.
Yes, thank you very much, Ruth, for this and for your comments. Okay, more questions for Ruth? Is there any other comment or question? Okay, because if not, I would like to present to you one new member of EPIC. So Philippe from Skyline Optics. Is this a good moment for you to present? Philippe? Okay, maybe not. We will come back later with Philippe. And Tom from US Connect. Are you here? Okay, so maybe not. We also will come back.
We have Philippe. I think he was muted and he didn't notice that we have him.
Hello, how are you doing, Philippe?
Fine, and you?
Very good. So, well, I was just saying that you are a new member of EPIC. Thank you for joining. And, well, maybe it's a good moment for you to introduce what your company is doing and what are you looking for in this meeting.
As you know, we are involved in optical transceivers since more than 10 years now. And we have been involved in new technology also. And as you know, we are based in Europe, and you know that Europe is trying to go ahead and try to show some new technology also. Then we have been working with some companies already here. I say I don't see them in the call here, but we've been making some co-development with Effect Photonics, you know, who are based in Netherlands and in UK, okay, on PIC technology. We work with IMEC in Leuven also, on FPGA and ASICs also. And then we are very interested in co-packaging, because we are looking for new technology also to come with some unique design for specific market also. And for us, it's very important to be part of the EPICs. And sure, since 1 year, EPICs has been directing more and more on more oriented in telecommunication with the silicon photonics, with PIC technology, with co-packaging. And I think so we have a lot of companies in Europe who are involved in this technology, where we can make the differentiation by collaboration. And the reason why I joined, it's really because we are looking for collaboration in Europe, and it's very important for us.
Okay, thank you very much for all these comments. If you want us to connect you with any of the companies in the room, just tell us, and we will be very glad to do it. Okay.
Thank you very much.
Thank you, Philippe. So, okay, more questions, comments? Okay, so if not, let's move forward in the program. So next speaker is Tiger Ninomiya from Senko. So Tiger, if you can share your screen.
Sure. Can you hear me and see my presentation now?
Yes, everything. Perfect.
Okay. Thank you very much, Anna. And hello, everyone. Hello, YouTube. And this is Tiger from Senko Advanced Components. Senko is a fiber optic connector manufacturer providing multiple different interconnect solutions. And at the last meeting for Beyond 400 Gig, I presented lots of different connector options that Senko has. But when it comes to co-packaged optics, I think one of the topics some of the speakers also spoke was densification of the fiber coupling. So one of the approaches to get higher density is to consider the use of the multi-core fibers. And I will talk about a little bit of what is this type of fibers are and where that kind of standardization is, and also some activities that Senko did in the past. Let me skip this page. So there are multiple types of multi-core fibers in the market now. Just like shown on the top right, there are 4 in line and 4, 2x2, 2x4, 7. I didn't create anything but the 12, 19, and many different types now. However, there's no standard specifying what to do, what fiber pitch or whatever. Although within IEC, I believe there's a huge discussion about to standardize the fibers and connectors, but there's no answer yet. So I think at the moment there are various fiber companies having multiple different options and also having different projects. But another point that we should consider when we are talking about multiple fiber is how to break out cores if needed. And the bottom ones are 4 typical ways to break out individual cores into different fibers. And one of the approaches shown on the bottom left is waveguide. So waveguide, glass, polymer, anything could be done, but the PLC approach is one. Also, there's a way to prepare some smaller diameter of the fiber to bundle to couple against the multiple fiber like this. And another approach here is free space optics. And the last one showing, it's not, I couldn't draw very well, but there's a way to stretch and fusion splice the fiber. So eventually it'll be spliced on. And going next, when it comes to connectivity of the multi-core fibers, of course, as you can imagine, the accuracy of the fiber alignment is very, very key. It's similar to PM fiber alignment, but it's more challenging because you have 7 different cores in this case to align to the opposing fiber or connector. So it's really challenging. And some of the papers I referenced says that if we can align within 2 degrees, we can achieve insertion loss of 0.85. If it's 1.3 degrees, it's going to be 0.2 dB. But this alignment tolerance should include how we align the fiber into the ferrule, connector ferrule itself, as well as if you are using the fiber optic connectors, there will be tolerance coming from the component, different components. So there are lots of things to be discussed to make good insertion loss using multi-core fiber. And also polishing is not something we can see as a easy way, because if we use like a typical UPC polish to achieve the better return loss, the fiber end face will be like this, and there can be air gap. So we need it's not so much special, but we need to consider a suitable polishing approach to have all the cores to have the physical contact. And as described here, there are multiple connectors out there, including the fiber arrays like these. But the lower the density, you can easily make connectors. But if you have multiple fibers assembled onto this, as mentioned, alignment is a key to achieve the better loss. So it's going to be more complicated in the future. And this is my last slide, and the questions to the members or somebody in the audience. But some people talk about multiple fibers for co-packaged optics application due to the densification. But is it really needed? And also, if needed, is it being used to have a fan out in between the modules, or multiple fibers straight away to the other end of the module? And also how to couple the fibers. There are multiple approaches to actively align, or the wire bonding. This particular image is coming from Vanguard Automation, but there's a way to have the wire bond from multi-core fiber to the optical chip. So this can be the lowest loss option, but these are the questions I have for the members today.
Thank you very much, Tiger. Thank you for a great presentation and thank you for your challenges. It is in my mind here, when it comes to the connector, a lot about costs. I honestly don't think that the multicore, but anybody could correct me if I'm wrong. I honestly don't think multicore fiber is going anywhere in this particular sector. But when it comes to the low cost approach, is there any technology of choice that you are considering as the key winning for the integration of the connector into the CPOs?
That's a good question. So I think when the fibers are being packaged, if there's a way to align the fibers or channels easier, that would be great. And also detachable, I would be rephrasing that as a socketable approach, so that they can test first, remove it, solder reflow, and attach the fibers again.
But when it comes to the cost, you raise a very interesting topic here. You put active or passive alignment. Where is the industry going? I'm going to ask Torsten Vahrenkamp from Ficontec. Where is the industry going? Is there room for both? Is there a need for both active and passive?
So all of our customers would love to go passive. At the moment, I don't have any product which goes high volume, which is really doing a passive attach. I don't know if you're aware. So we are shareholder of Vanguard, and with them we are actually trying to establish that a little bit further, especially the attachment of the multicore fibers. Other than that, I don't see anybody who's seriously doing a passive attach.
That's okay. Let's ask your present or future customers. I don't know. I'm going to go to Scaling Optics, and I love this company. I've been knocking at your door, Philip, so many years, and finally it happened. Philip, when it comes to passive and active alignment for the packaging, where does Skyline stand?
Yeah, you know, we have been working on passive alignment since a few years, okay? Don't smile, but we have been very active on also plastic optical fiber, okay? For the automotive industry. Then we've been working on a few European programs, Eurostar and ACFAST. Have been working on really trying to implement a very cheap solution for passive alignment, okay? With very cheap optics, also injected optics. And I love the presentation from SABIC. When I learned the cost price of the optics, it was very interesting, you know, because when we have done this technology 5 years ago, I can tell you it was not so easy to reach this level of specification with a good price. But today we try to optimize the passive alignment compared to the active alignment, because it's very important to reduce the cost. And you know that all the cost is in the alignment.
No, well, yes, all the cost in the alignment, because the cost is related to the speed, which is the most expensive parameter in manufacturing. I'm very interested on the vision of HG Tech, another one of the key giants that we have in EPIC. Jim, where do you stand on the active versus passive alignment for CPOs, especially?
I've kind of a hybrid of the two. I would go active alignment, but you set the optoparameters so much that you have a very wide space to hit. So you use all the tricks you would use for passive alignment to make it really, really accept a lot of slop, but then you do an active alignment. And that now lets you have the precision of an active alignment, but it'll let you make the process very fast. Because as you said, you know, well, as I was just said, the cost of alignment in a complex optical engine can dominate over the cogs. On more simple older generation parts, it doesn't come into the equation. Your cogs driven, but for what we're talking here, the next generation of really fast optical engines, the alignment cost dramatically dominate a lot of these. And I think the same would be true for CPO. Yeah.
Let's go to another transceiver manufacturer. Let's go to Sequoia. In the beginning of the presentations, Marco, you said, I'm doing for the vertical grating coupler packaging. Are you also going for passive alignment, or is something, as Jim said, something mixed?
No, so I see personally a big advantage in active alignment. So we have to consider that We need to maintain interoperability with existing standard in data center. There, we don't have much link budget, so we don't have much margin to guarantee that. So we have to squeeze all possible fraction of dB out of the transceiver. So therefore, I guess, especially due to the large number of counts, active alignment will be the dominating technology.
I honestly think that there is the future is actually active alignment for the co-packaged optics, but I also think that we need to go faster. There has to be a paradigm shift on this as well, on the speed for the assembly. But Sequoia is going definitely in the right direction. And we move to the last presentation today. So pity, it is such a pity that this is finishing because we are making such a great statements today. But we go to Optiwave, we go to Sam Bonfil. Thank you very much for joining the meeting today. From the software side, let's bring the industry together. The attention of everyone is yours.
So, well, thank you very much for giving me this opportunity to present. I want to talk about Optiwave, and we're bringing, as you suggested, Jose, we're bringing a different perspective to this meeting. And let me share my screen. Okay, here's my, okay. Because what we're doing actually is bringing optics and electronics together in software. So initially, I want to go through, talk about our company just very quickly, and then later talk about the product I'm managing right now and what we're doing to address co-packaged optics in general. So our company was established in '94 in Canada. And our main business is developing software tools for designing optics and electronic circuits and systems. We help people shorten their design cycles in various ways. We sell to 100 different companies in the industry and 75 different countries worldwide. So some of the fields we serve are photonic component and module suppliers, optical telecommunication equipment providers, telecom service providers, defense contractors, nonprofit organizations, and universities. So there are two main product lines we have. One is at a component level. So it's for designing your individual devices. We have OptiBPM and OptiFTTD, where you can design your structures in 3D and see how the light scatters in your device. We also have an OptiFiber for designing fibers, and then we have OptiGrading for grading. So at the higher level, we have OptiSystem and OptiSpice. OptiSystem is the highest level simulator we have. It's for designing optical telecommunication systems as well as sensors. OptiSpice is the product I'm going to emphasize today, and that's the one I'm in charge of. It is made for designing and simulating optics and electrical circuits. And then we have a new software that we're launching called OptiInstrument, which is used for automating test equipment and characterization. So our simulation capabilities, again, they range from system to circuit level and device level. We can do optoelectronics, that's mainly with OptiSpice and OptiSystem. So if you have ring resonators, laser drivers, optical interconnects, optical networks with OptiSystem, and same as OptiSpice, optical amplifiers, more different. We can handle different modulation formats. We can also do DSP with OptiSystem. We support wireless communication and sensor applications. On the device side, we have FTTD, an FTTD simulator that can handle dielectric structures and gratings and photonic crystals. BPM is for devices with lower refractive index contrast. You could do, again, photonic devices, couplers, splitters, modulators, AWGs. We have OptiGrading, OptiFiber, and then we also have a mode solver that we use with OptiBPM and FTTD, or it can be used independently as well. Now, the product I want to talk about the most, and I'm very excited about it, it's OptiSpice. We have two versions of OptiSpice that we are offering right now. One is a standalone Spice, where we provide a complete solution in terms of there's a schematic editor, a SPICE simulation engine for simulating electrical integrated circuits, and we have our own models on top that can do optics. So the optics is bidirectional, multi-mode, multi-channel. We have parameter extractors, and we have connection. OptiSpice is connected to OptiSystem, where you can build your system and then design your optical chip in OptiSpice and then connect it all together. And it's also connected to BPM, FDTD, and grating. You can build your devices, extract parameters, S parameters, for example, and then plug that into OptiSpice. The other product that is newer that we launched in 2019 is a plugin. So one of the main reasons, there are a few reasons we did this. One is we would like to partner up with larger EDA vendors and bring optical simulation capabilities at the same level as electronics, because one of the successes of the electronics can be attributed to very advanced design and simulation tools, starting from circuit, going to mask layout, automation of the layout, design rule checking, and a lot of the optical optical design tools we need are the same. However, for many, many years, the optics and electronic simulation tools have been separate. So our OptiSpice plugin is a model library that plugs into other SPICE engines. So with that, you're able to use a third-party schematic editor. So it could be Cadence, Mentor Graphics, or other flavors. Right now, we are in direct collaboration with Cadence, so with Mentor. And we're also working with other companies to work with and put products out. So this is kind of how we're trying to bring optics and electronics together. You know, not at a not physically, but on the software side. The advantage of doing optics and electronics in the same simulation engine is how natural it is to handle electro-optic feedback loops. You can design your control circuits. It could be electronic, or it could be you want to design control for a ring resonator where you want to do a thermal control. It is perfect tool for that. Like I said, we can do multi-mode, bidirectional, linear and nonlinear devices. And you can use CMOS electronics or just any electronics and optics in the same tool. We do time and, like any other SPICE engine, we do time and frequency domain solutions. This is an example of the full SPICE. So we can do microwave photonics, optoelectronic sensors, and telecommunication circuits and systems. So I have an example of a fiber optic gyroscope where the fiber is a very large coil, and as it rotates, you can control the incoming laser frequency, and it lets you calculate the rate of rotation. And on the right side, I have there it is. On the right side, we have a model we built using experimental data. That is also very important. So this is also an electro-optic circuit. This is a receiver circuit that we built using optoelectronic measurements. Now let me talk a little bit about the plugin. Again, it is a native add-on for SPICE engines, and the idea is we want to be able to support photonic integrated circuit design flow and take the photonic design flow at the same level as electronics. So it can support photonic integrated simulation from mask layout. You can directly extract your circuit and then build your electronics around it, or you can extract the whole thing at once. Also, it allows rapid prototyping directly from the schematic. So we have built-in device libraries going from linear to nonlinear optical devices, lasers, photodiodes. We have passive and active model building capabilities for photonics components using OptiBPM, FDTD, OptiMode, and OptiGrating. You can also integrate your characteristics or measurement results to build a model. The other part, of course, is we're also trying to work with fabs so that we can build PDKs that match the experimentally verified results of a particular device. And the users of the PDK can easily have set of building blocks and drag and drop devices, connect them together on a mass, and get their design running very quickly. Finally, I just want to briefly talk about our flow with Tanner. though this flow is pretty much how you would design an electrical circuit as electrical IC as well, or it's very close to it, starting from a mask layout. Here's there's an example of a Mach Zehnder interferometer. Tanner has a simple, 2-click method of exporting, 2-click method of exporting the net list, and then you can build your layout. So you can build your schematic and set up your inputs and outputs for the chip and control the chip, run your simulation, and look at your results. You can also just start from, we have a set of symbols that you can just use, drag and drop and connect them together just to do prototyping without worrying about the mask design. So that's the end of my presentation. What I wanted to say, just to sum up, maybe what we're looking for right now is to collaborate with companies to help them solve problems involving specifically integration of optics and electronics, because of the unique way we bring them together using software. The other part we're looking for is, of course, working with fabs, and working with, the request for working with fabs can come from somebody who's actually trying to design for a particular fab or the fab themselves. And we want to build PDKs such that everybody can benefit from a faster design flow.
Thank you very much. Obviously, we're be making a paradigm shift on the design side to go towards having what I call not a PDK, but an ADK, really like an assembly design kit, to have your assembly in mind when you are designing the chip. And on that, I really think that you really need to engage further with ASE, because that's the kind of company that goes beyond the photonic integrated circuit and goes, as you have seen today in the presentation, on what is the concept for the integration of the photonics and electronics. I have been in a great meeting today, but I think the best way to finish this meeting is to go to my friend from TE Connectivity, Nathan Tracy. Nathan, what did you think about the meeting? What kind of learning points are staying in your mind after this?
Yeah, so hi, Jose. Hi, everyone. It's great to join another one of these fantastic epic calls. Yeah, so I heard a lot of interesting data points today from the various companies that presented and that asked their questions. So, kind of building on the conversation, if you look at all the press releases that came out of OFC, even though the attendance at OFC was impacted, all the good work that people did to show their co-packaging wares or co-packaging capabilities, and now, so that was back in March, and now you look at the tempo and just the enthusiasm on these calls. Clearly, the technology is coming together. This is just really exciting. At my company, TE, we're focused on electrical interconnects and we're focused on thermal management, but there's so many people here that we can work with. And just like we did at OFC, where we were in all those co-packaging demos with the electrical interconnect, I wanted to be able to connect to all of you and see how we combine the technologies together. Because really this is about finding the common ground and bringing things together. And leveraging the industry standards, Ethernet Alliance, COBO, OIF, and all together we're moving this thing forward. We're going to make co-packaging happen.
Yeah, indeed, we are going to make co-packaging happening. Patrick, from the point of view of Delo, you have been active in many different markets, and you can enable many different automated packaging solutions with the adhesive of solutions of Delo. What did you think of the meeting, and what kind of learning points did you bring back with you?
I mean, this was another fantastic meeting. Thank you, Jose, for putting this up. For us, it's always interesting as a supplier of UV polymers, adhesives, and materials for micro-optics to see where the industry is going. And I've seen several points here where epoxies were mentioned in Torsten's talk from Ficontec, for example. So it was fantastic to see where the challenges are and where we can help to foster this technology and bring it further to the next level.
It was truly fantastic. I took a lot of notes. Today I got more learning points that I could take in one slide. I think we could write a book. But for me, the key thing here is that the market is really driven by both cost and losses, not only cost. Losses are key. And it was quite clearly stated between the lines, because we are all very careful. Well, I'm not careful at all, but you guys are very careful. CPO and COBO are the future proof or the intermediary steps, and it looks towards more the intermediary step. And there are views shared that the future is a further integration of the optics and electronics. I pointed out there the work on BiCMOS, but there are other works. We need to go towards, I think, a further integration. But today, with high TRL, we're closer to implement the COBO, although Mark said that maybe we're going to leave enough even to see the COBO deployed. Second thing was about the transceiver form factor. There is still a debate there, so we still don't know where we're going, and I would like to have Arista in the room. So you guys are seeing me, Arista, I want you here. We don't know where we are going, QSFP or OSFP or QSFP-DD, and this actually affects a lot the defining of the standard of the onboard optics, so we need an answer for this. Arista, I want you here, please. Next one, the PLIC platform of choice. We had a lot of discussion about silicon photonics or indium phosphide. It was I love the presentation from Cisco, that slide in which they said 105 degrees C and very high integration with ICs. It was very clear that we have to go towards a silicon-based, silicon photonic-based platform, perhaps with integration of indium phosphide. But about the light source, and that I also pointed out from the Cisco presentation, high efficiency, high reliability, thermally insensitive. And they were talking about having the light source very far away from the CPOs, which for me is perhaps a trend that needs to be explored. Standards are still the big thing because the electrical part seems to be fully solved. We have a standard for that, but for the optics, I think COBO is doing a great job. Ethernet Alliance, we are working together with the EEE. We're going to communicate a lot more things, but there's a long road to drive through. The next big thing, and thank you, Ruth, for a great presentation, and also for Senko for pointing that out, the collaboration also with Vanguard Photonics. The next big thing could be 3D lithography in volume production. I think Multiphoton is very well positioned there with other companies along that value chain. And finally, there are questions. There are questions on the packaging side, questions for Anna to solve with the PIXAP community, questions about passive or active alignment of CPOs, and definitely a question about the peak packaging. Are we going for the grating coupler or are we going for the edge coupler? For me, nice questions to answer, nice Ruth, nice ways to collaborate, nice things to do together. It has been another fantastic meeting, another epic meeting because you guys are epic and because I'm having so much fun with these meetings. Thank you so much for driving this industry. Until the next time, Jose and Anna, love you. Take care. Bye-bye.
Thank you, everybody. Have a nice day.
Thank you. Bye-bye.